Git is a repository tool or version control tool. So what is repository? Where we store our data, where we store our source code is nothing but repository. It can be any data. It can be binary files, image files, video files, audio files, spreadsheets, right? Where we store our data. Version control is nothing but track the changes over time. It track the changes over time, right? Yeah. So multiple developers, they work on multiple activities. Okay. So front end, back end, database, they work on multiple activities, right? Who is doing what? How can we track? So by using version control system, we can track the changes. Okay. Fine. Next one. Yeah. So Git developer, yeah, Git developed by Git kernel developed by Linux Store Worlds. Kernel developed by Linux Store Worlds, right? So who developed Linux kernel? The same guy developed this Git kernel also, right? The person who developed Git kernel, right? Same guy developed this Git kernel also. Fine. So yeah, Linux Store Worlds developed the Linux kernel as well as Git kernel, right? So that is why in Git we can execute the Linux commands also, right? Linux commands can be executed in the Git, right? Yeah, fine. Now, developer develop the code in their local workspace, right? What is workspace, anyone? Workspace is nothing but local repository, right? Local system. So Git local. Developer A and developer B both are working on their local Git. So once development is completed, what they will do, they push the code to remote repository, which is GitHub. Yeah. Now let's try to understand how to install configure Git first. Okay. So this is a remote repository, or we can say GitHub. Remote repository or GitHub. Fine. Yeah. Now let's try to understand how to install Git and how to install Git. Let's try to understand. Okay. So first of all, we can go and install configure Git. Okay. Yeah. Go to browser. Now download Git for Windows. You can search here, download Git for Windows. Look at my screen, everyone. So Git install for Windows. So Git is a small exe file. Git is small exe file that we can download into our local system and we can install. Jenkins onwards we can install on, yeah, AWS servers. Okay. So only Git small exe file you can download into our local system. So git-sem.com is the official URL. So we can use this. Don't use the third-party URLs. Okay. Git-sem.com is the official URL. We can use this URL. Okay. Now click on the URL. Now look at my screen, everyone. Standalone installer, portable installer. Two types of installations are available. Standalone and portable. So don't take this second one, standard portable. We can always use the standalone only, right? So in this standalone, two versions are available. Git for Windows x86, x84, sorry, Git for Windows x64 setup, Git for Windows ARM64 setup. Two different versions are available in the standalone installer. So click on first one. So you can download this. Now the Git is downloading. Git is downloading. It is a small exe file. Git is downloading. Yeah, now Git is downloaded. Now the Git is downloaded. So once Git is downloaded, you can go and install this. Just go and double click on this. Go and double click on this setup file. Click on yes. Click on install. Click on install. Okay. If you want to check this, you can read, can go through and you can read this and click on install. So once you click on install, the Git will be installed. Okay. So I already installed in my laptop. Again, it is installing. Git is installing. Wait for 1 or 2 minutes. Yes. Yeah, Git is installed, right? Finish. Finish this. Okay. So Git is installed successfully. So now once the Git is installed, now if you go and check in your desktop, right click on your desktop click on desktop, show more options. Look at here. Git GUI here, Git Bash here. So these two tabs available. Once Git is successfully installed, you can check it out. You can check it out. This both the tabs are available. Okay. Git GUI here, Git Bash here. So in real-time projects, we don't use the GUI, graphical user interface. We always use the CLI, which is Git Bash. Fine. Yeah, Git is installed successfully. Now, once the Git is installed, next one. Let's try to understand Git workflow today. Git workflow. Git workflow, right? So here, look at my screen. Yeah, so this is a local workspace. Local workspace. What is local workspace? It is a local system. Local system. In the local system, we create a folder which is local workspace. Okay. Yeah. So in local system, what I will do? I create a folder. So this is a local workspace. For example, look at my screen, everyone. So this is my local system, local laptop. I just want to create a workspace here. Local workspace. In this local workspace, if I add any folders, files, if I remove any folders, files, if I modify any files, folders, those changes will be tracked or not. So anyone, if I add any files, if I remove any files, if I modify any files, the changes will be tracked or not?
No.
No, right? So because this is a local system, local folder, right? So this is a local folder, normal folder. This is a normal folder. So this normal folder we need to convert into repository, right? Yeah. So this is a normal folder. In the normal folder, so what we have to do? So we need to right click in this folder and we need to open the Git Bash here. After that, what we have to do? We need to initialize. Git init is the command. To initialize empty Git repository, we need to initialize. Okay, Git init is the command to initialize empty Git repository. Fine. Yeah. So once we initialize, immediately we need to create one user and we need to create one email ID. So that is mainly for tracking, right? We require one user and email address also, right? So once we initialize, we need to create one user. How to create the user? Let's try to understand. So command here is git config space hyphen global space user dot name, right? Space within the double quotes, we need to give the username. Whatever the username you want to give, you can, right? So after that, git config space hyphen global user dot email. Within the double quotes, we need to give the email address also, right? So whatever email you want to give, you can give. Even dummy email also fine, right? So if you want to check the user, for example, if you want to check the user which is available in your workspace, so git config space hyphen list is the command. Git config space hyphen list is the command. So one workspace, one user only. One workspace, one user only. One laptop, one developer only. One desktop, one developer only, right? Yeah. So this is completely developer activity, and it is not our activity. So this is completely developer activity. It is not our activity. This is not our activity. So completely developer activity. Developers always work on Git and GitHub. So our role starts from Jenkins onwards. Our role starts from Jenkins onwards. Okay, fine. Now, so once we create the user, right? So development should be started. Okay, fine. Now we already created the local workspace, right? So now what I will do, open this local workspace. So right click on this in this folder, right click here. Now open in terminal, open in terminal. That is not correct actually. So don't confuse. Normally, if you want to connect your Linux server or EC2 instance, normally we open this terminal, right? But if you want to connect your Git bash here, show more options. Now click on Git bash here. Open Git bash, right? Now Git bash open. This is the Git bash. So you can increase the font size like this. Okay, fine. So we need to click on the folder, local workspace. Inside of the folder, you need to right click, go to more options, right? Show more options. Now you can click on Git bash here. Okay. So now it is showing the path, local workspace path, right? Now here what we can do, the command here is git init is the command. Git init is the command to initialize empty Git repository. Enter. Now it is initialized empty Git repository. Initialized empty Git repository. Right? Yeah, once it is initialized, next what we can do, development should be started, right? So before going to start the development, so we need to understand the development actually. We don't need to do the development activity in real-time projects. So as a DevOps engineer, we don't need to worry about the coding part, right? So developers always develop the applications. They work on coding part. But as a DevOps engineer, we don't need to worry about the coding part. Clear, right, everyone? Yeah. Now, what we can do here, next what we can do. Yeah, so very first thing we need to create one user, right? So I already having user. I just want to show you git config space -- list is the command to get the user. Look at my screen, everyone. So this is the user already there. If I create one more user, what will happen? Any guess, anyone? Real time guess. If I create one more user, what will happen?
With the same credentials?
Should be override.
Override, yes. So because one workspace, one user only. One workspace, one user only. If you create one more user, so that will be override. Old user will be gone, new user will be available. Now I just wanted to show you, okay? I want to create a new user. What will happen? Let's try to understand. So git config space -- global space user dot name space within the double quotes, we need to create a user, which is a RAM user already there. Rama user. I want to create Rama user. Okay. Enter. User created already. User created now. Okay. Now I want to create email ID also. User dot email. Give the email ID also here. Fine. Enter. Right. So now email ID also created. Now if you go and check here, git config space -- list. Look at my screen, everyone. Now it is showing username Rama, email ID Ram, right? So old one, look at my screen, everyone. Old one is Ram user, right? Yeah. New one is Rama user. Old one is gone. Only one user is available. Okay. So by using this, we can track the changes. So if I change anything, so definitely that will be tracked. Anyone can track. Okay. Fine. Now, once we create the user, once we create the email ID, so development should be started. Okay. So now, yeah, vi file.txt. So developer create a file, in that they start the development, right? Vi file.txt. Enter. Now insert, click on I. Now, hi, this is my first program. It is not really program, it is a text. Okay. We are not developers. We don't need to worry about, but we need to understand the process. You need to understand the Git functionality. You need to understand the GitHub functionality, right? Fine. Now, escape shift colon WQ, save and quit. Now the file is saved. So yeah, now once we create the file, once we add some data into the file, once we add some code into the file, right? It is not code, text added. Okay. Now we can check here Git status. Git status is the command to check the status of the development. Okay. Look at my screen, everyone. Now it is showing, the file is showing red color. Red color means still development is going on. Still development is going on, right? Yeah. So developer still working on the development activity. Once development is completed, what will happen? The file will be changed to green color. Understanding, right? Yeah. Now look at my screen, everyone. So here we created the file, right? So vi file.txt, right? So once we create the file, so once we add the data here, so we check the command here, git status is the command. So when you check the git status command here, it will show you, file will show you in red color, right? So red color means still development is going on, right? Now, once development is completed, once development is completed, what we have to do? Yeah, once development is completed, the data should be moved to the staging area. The data should be moved to the staging area. What is staging area? Why we required staging area? Let's try to understand. So this is a staging area. Staging area, or we can say index area. Index area. Staging area or index area. So how can we move the data to staging area? What is staging area, first of all? So staging area is a Git workflow. That's it. Nothing to worry. So different workflows are available. Different stages are available. I'll show you in the Git workflow. Different stages are available. I'll show you. Okay. Now, once development is completed, if you want to move the data to staging area, the command here is git add is the command. Git add space file name, or we can give dot, file name or dot. Okay. So if you give file name, only the respective file will move to the staging area. If you give dot, what will happen? All the files will move to the staging area. Okay. Fine. Now what I will do? So currently the file is in local workspace. Now I want to move this file to staging area. Git add space file name, file.txt, enter. Now the file is moved to staging area. Now if you check here, git status, the file will show you in which color? And yeah, the file is showing in green color. Look at my screen, everyone. Yeah, this is red color, this is green color. Means what happened here? Development is completed. Now it is ready to commit. Development is completed. Now it is ready to commit, right? So now if you check here, git status, now it is showing green color, green, right? So green color means development completed. Now it is ready to commit. Got it right, everyone? Yeah. Now it is ready to commit. Fine. Yeah. Fine. So here, yeah, once we move the code to staging area, if you want to revert back to previous state, okay, the code is moved to staging area. Now I want to revert back to local workspace. Understanding that, everyone? So the currently code is in staging area. Now I want to revert back to local workspace, for which the command here is, look at my screen, everyone. Git rm space hyphen cached file name. This is the command. Git rm space hyphen cached space file name. Okay. So look at my screen, everyone. So currently the file is showing green color, right? Git rm space hyphen catched space file name, file.txt. Okay. Enter. Now it is moved to previous state. Now if you check here Git status, the file is showing red color. The file is moved to local workspace, right? Now it is showing red color. Now we can edit this. vi file.txt. You can add something here. Insert something, you can add second change or something. You can add here escape, save and quit. Now it is saved. Okay. Now we can move to staging area. Git add space file name, or we can use dot also. Enter. Now the file is moved to staging area, right? Yeah. Now if you check here Git status, the file is showing green color. So understanding right, everyone? Any confusions here? Anyone having any confusion so far? So far, any questions, any confusions here? Is it clear to you? So Git is completely developer tool, right? We don't need to worry about coding part. Okay, so but you need to understand the workflow, right? That is why we are working on Git. So developers always do the mistakes. We need to correct them. Okay, we need to understand the development area, development activities. Okay, that is why we are working on Git. Okay, fine. Now the code is moved to staging area. So once the code is moved to staging area, after that, the code should be moved to commit area. The code should be moved to commit area. So this is commit area. Commit area, or we can say Git local. Commit area, or we can say Git local. So this is Git local. This is Git local, right? Git local. So before Git local, we have two stages. What are those, anyone?
Staging and committing.
Yes, staging area. And also local workspace. Right? Yeah. So now the code should be commit. How can we commit? So the command here is git commit -m is the option. Space commit message we need to give. So commit message should be meaningful message. Okay. Commit message should be meaningful message. I'll show you. How can we execute? So once we commit the code, we can go and check the Git log here. Git log. When you execute Git log, what will happen? It will show you who did changes, when did changes, what purpose did changes. It will show you. The tracking will be started. Once the code is committed, tracking will be started. Okay. So who did changes, when did changes, what purpose did changes? We can check it out then. Okay. Fine. Now go back here. So currently the file is in staging area. Now it is showing green color, right? Now git commit -m commit message. I can say first program. Enter. Now the code is committed. Now if you check here Git log, it will show you who did changes, when did changes, what purpose did changes. So there is a commit ID generated here. This is the commit ID and author name Rama, right? So email ID also available. Date and time, you can check Monday, July 13th, 2036. He made some changes, saying something like first program. So like this, we can track, right? So for example, so 5 developers are working on the application development. who is doing what. We can easily track like this. Clear, right, everyone? Clear, right? Yeah. Once the code is committed, next what we can do, and anyone? Once the code is committed, the code should be moved to,
Git push.
yeah, the code should be moved to the remote repository, which is GitHub. We need to push to the GitHub, right? So this is GitHub. Right. So up to here, any questions, anyone, you can ask me. So before going to GitHub, first you need to understand this process. If you have any confusions, definitely I clear the confusions. Up to here, any questions, anyone? This part, any questions, anyone, you can ask me. Anyone? I'll repeat it one more time. Fine. Yeah, I just want to repeat one more time. Look at my screen, everyone. So this part is very important. Coming 4 days, we'll work on the same workflow. Every company, every project team, every developer should follow the same flow only. Okay. So that is why first we need to understand this flow. So up to here, it should be clear. It should be clear. Otherwise, yeah, we cannot move to other concepts. Okay. So that is why I just want to recap one more time. Okay. I just want to recap. Yeah. So now, first of all, what we can do, look at my screen, everyone. I just want to close this. I just want to delete this. Yeah. First of all, when developer join into the project, what they will do, very first thing they need to create one workspace. What is workspace, anyone? What is workspace? Anyone? What is workspace?
Source code where you store on the.
Yeah. Workspace is nothing but where we store our data, right? So local workspace, local system. In the local system, we create a local folder, right? So this is workspace. This is a workspace. So in this workspace, if I add any files, if I remove any files, if I modify any files, those changes will not be tracked because this is a normal folder. That is why what we have to do, this local folder we need to convert into local repository, for which what we can do, open this folder. In this folder, we can right click here, right click here. Now show more options. Click on Git Bash here, Git Bash here. Now Git Bash is open. Right? Now we need to init it, right? Git init is the command to initialize empty Git repository. Now it is initialized. So once it is initialized, one .git file will be created in the folder. One .git file is created. Okay, look at my screen, everyone. .git file is created. If the .git file is not created in your system, what you have to do? Go to View and click on Show and check this hidden items. Check this hidden items so that it will show you .git file. Okay. Yeah. After that, what we have to do? Yeah. So we need to create one user. How can we create the user? Command here is git config space -- global user dot name. Within the double quotes, we need to give the username Ram and email ID also we need to create user dot email. Enter. Yeah. After that, if you check your git config space -- list, now it is showing latest user, which is Ram user. Look at my screen, everyone. Ram user. Okay. Now, once we get the user, development should be started. Okay. Vi git.txt, any file. So developers, they create the files, their own, not their own, as per the project policies. Okay. Enter. Now insert hi. This is my first application development, something. Okay. Escape, save and quit. Now the file is saved. Now if you check your git status, the file is showing red color. Means still development is going on, right? Once development is completed, what we have to do? we need to commit, we need to move the code to staging area. Staging area, right? So Git workflow, we need to understand the Git workflow, right? So from local workspace, the file should be moved to the staging area. How can we move? Git add space file name r dot. The file is moved to staging area. Now, if you check your Git status, the file is showing green color. Means, yeah, the file is moved to staging area. Now it is ready to commit. Okay. So now if you want to unstage this, what we can do? Anyone? If you want to unstage, if you want to move back to
Get rm minus cached and file.
exactly this command we need to execute. So currently the file is in staging area. If you want to move back to local workspace, we need to execute this command, git rm space hyphen cached file name. Once you execute this, file will move to local workspace. Even once you commit the code also, we can move to local workspace. I'll show you later. Okay, fine. Now the file is moved to staging area. Next, what we can do? We need to commit the code, right? How can we commit the code? Git commit -m commit message. First application something. Now the code is committed. Now if you check your Git log, now it is showing who did changes, when did changes, what purpose did changes. Based on these comments, Git will track the versioning. Clear, right, everyone? Yeah. Next, what we have to do? Any questions, Andy? Clear, right, everyone? So far, it is clear, right?
Ram, one doubt here. Which
Yeah.
file we modified, that data will not be tracked in the log, Ram, because
Yes.
we have a multiple files, right? Like that should be tracked, right? Like where it code changed.
Yeah, whatever the changes you made, when you commit the code, one committed will be generated. So
Okay.
only at a time, only one file we can modify, right? Only one file you can modify, right, at a time. So every changes will be tracked. Nothing to worry. I'll show you. Going forward, you'll understand. Okay?
Okay.
Fine.
Yeah, Ram, I'm Srikanth here.
Yeah, go ahead,
Actually,
please.
your stage here, right? So we have normally we have SIT, UAT, and research, right? Here we need to
That
move
is
only
different.
stage area,
No,
different.
no, that is different. This is Git workflow. In
Okay.
server environments, development environment, UAT, QA environment, staging environment, and pre-prod, that is different. Okay.
Okay.
But in
Okay.
Git workflow, staging is different. Okay.
Okay.
Yeah. Fine. So now, clear, right, everyone? Any other questions, anyone? Yeah. Next one. The code is committed here. The code is committed here. Right? Once we commit the code, next what we have to do? We need to push the code to remote repository, which is GitHub. If you want to push the code to remote repository, so very first thing we need to create one GitHub account, which is free. Free account we can create. Okay. So how can we create the GitHub account? Let's try to understand first. Okay. So GitHub is the remote server, Andy. Remote server, not local server, remote server. Okay. So go back to the browser. Now here github.com is the URL. github.com is the URL. Enter. So this is my GitHub account. Yeah, first time when you open this URL, it will show you like this. First time when you enter this, when you give this URL, will open like this. First time we need to sign up. We need to sign up. Click on sign up for GitHub. Yeah, so you can use your Google account, or you can use your Apple account, or else you can go and create your own account. Okay, you can give your email ID, password, username, country, right? So you can GitHub Copilot if you want to use, you can use. Click on create account. This is very simple, very easier. To create GitHub account, it is only 3-4 steps. That's it. Right? Once you create the account, click on sign in. Click on sign in. Yeah, give your username, password, I saved my username password. That is why it is showing like this. Okay. Click on sign in. Once you click on sign in, it will ask you to provide your authenticator, two-factor authenticator, right? So we need to provide the authenticator here. So like MFA, like MFA. Okay. So here we need to provide 054 447. Yes. Now I'm able to log in my GitHub account. Okay. Yeah. So these are all repositories available since long. I'm using GitHub account. These are all different batches, different repositories. Okay. I click on show more options since long. Yeah. Since 2016, I'm using this. 2016 onwards, I'm using this account. Look at my screen, everyone. 2016, right? Very old report, very old account. So different multiple batches. Okay. Fine. So now once we sign up the account, once we log into the account, very first thing we need to create one repository. We need to create one repository. How can we create the repository? Repository, right? These are all repositories. We require one repository. If you want to push the code to GitHub, we require one repository. How can we create the repository? Yeah. So here, right top corner, there is a plus symbol. Look at my screen, everyone. Right top corner, there is a plus symbol. Click on this. Now click on new repository. Click on new repository. Now it is asking you to give the repository name. I want to give DevSecOps 114. DevSecOps 114. I want to give repository name. Repository name. Okay. That description not required. We don't need to give any description. Now choose visibility. Choose visibility. So you can choose always public, which is default one. You can choose always public. So public is the free. Public repo is the free. So private repository is not free, right? So public is free, private is not free. In real-time projects, we always use the private repo, right? So public is not secure, private is secure. Okay. So public is free, private repository is not free. If you select private, what will happen? It will ask you to provide the credit card information. Okay. Don't select private. You always select the public. Okay. Select public. So click on create repository. Don't need to change anything here. Click on create repository. Now the repository is successfully created. Successfully created. This is the GitHub repository URL. Clear, right, everyone? GitHub account is created, repository also created. Fine. Once we create the repository, once we create the account, so very first thing what we have to do, we need to establish the connection between local Git and remote repository. We need to establish the connection between local Git and remote GitHub. Okay. How can we establish the connection between local and remote? Command here is git remote add origin. So origin is the variable entity. Origin is the variable. What is variable, anyone? What is variable? It is a value holder, right? So git remote add origin. In place of origin, you can give your name also. In place of origin, you can give your name also. But origin is the standard name. Don't give your personal name, your name or personal. Don't give anything. So you can give your origin only, because in real-time projects we always use the standard name, which is origin. Okay. Git remote add origin space remote repository URL. This is the remote repository URL. Right. To establish connection between local Git and remote repository, we need to execute this command. After that, once you give this, if you check here, Git remote, it will, yeah. When you check the Git remote, it will show you origin. Will show you origin. Means in the origin, this repository URL will be stored. In this origin, remote repository URL will be stored. Understanding that, everyone? Yeah. After that, what we can do? Git push -u origin to master. Git push -u origin to master. What is master? మళ్ళీ మాస్టర్ ఏంటి? కొత్త వర్డ్ వచ్చింది. What is master, anyone?
Branch.
Yes.
Main
Exactly.
branch.
Main branch. Master is a main branch. Tomorrow we'll discuss about branching strategies. Okay. Git push -u origin to master. If I execute this command, what will happen? In GitHub, master branch will be created. In that branch, data will be pushed. So tomorrow we'll discuss about branches. Okay. Fine. Now we can execute these commands. Now I want to establish the connection first. After that, I want to push the code to GitHub. Okay. Now go back to local Git. Now I want to establish the connection between local and remote repository. For which command here is git remote add origin space remote repository URL. This is the URL. Copy here. Enter. So now the connection is established. Now if you check Git remote, it will show you origin. Look at my screen, everyone. In this origin, this URL is stored. We don't need to give every time this URL, right? So already the URL is stored in the origin, right? Now I want to push the code to remote repository, for which the command here is git push -u is option origin to master. Enter. Now the code is pushing. Done. So the file git.txt, this file pushed to the GitHub. Okay. Now go and check in the GitHub. Just here refresh here. Now look at my screen, everyone. It is pushed, right? The code is pushed, right, everyone? Look at my screen, everyone. In this repository, our file is git.txt. If you click on this file, it will show you something like, hi, this is my first application development. So here in the local Git, if you want to check that, git.txt. Look at my screen, everyone. Hi, this is my first application development, right? Same file pushed to the GitHub also, right? Clear, right, everyone? Any questions so far, anyone? "12 minutes ago, we developed this. 12 minutes ago. So here author name, branch name, master branch. Only one branch is available. So tomorrow we'll create more branches. Clear, right, everyone? So make sure everyone practice this. If you practice this, you will understand tomorrow's session. Otherwise, you'll be confused. Okay. So Git workflow is very, very important. So yeah, this workflow is very, very important. Every developer, every project team, they are following the same process. Okay. So make sure everyone practice this so that you will understand branching strategies, Git configs, different concepts are there. Coming 4-5 days, we'll work on this. Okay. Clear, right, everyone? This weekend, we'll be having a session, Andy. This weekend, we'll be having a session. Let you know timings. Maybe 7 p.m. to 9 p.m. planning. Okay. So we'll work on Jenkins. We'll start Jenkins and we'll work on Jenkins. Okay, so we can speed up. So because last week, before last week, so sometimes session was not happened, right? So I just want to cover all these gaps. Okay.
Ram?
Yeah, go ahead. Yes.
Yeah. The first screen commands, right? vi file.txt. After we entered some data, okay. After
Yes.
that, we gave shift colon wq, means we are saving the file.
Yes, yes, correct.
Okay.
That is
Even though we
Linux command,
are,
Andy. Linux command.
yeah, Webex command. Even though we are saving the file, why it is showing red color when we are clicking Git status?
Yeah, if the file is in local workspace, it will show you red color. Once the file is moved to staging area, the color will be changed to green.
Okay. Okay. Even though we are not saving also, it will come in red color.
Yes, yes, correct, correct.
Okay. Okay.
Yeah. So make sure everyone practice this. I'll share with you this notes. I'll share with you running notes. Okay.
Ram,
Yeah.
this the staging area. We are adding the git add file, right, from the local to this thing.
Yeah.
For committing it again. Wire for this git remote add origin. I mean git add and git remote add.
Git remote add. If you want to establish the connection, local git to remote repository, we need to give this command. So if you want to move the data from local workspace to staging area, git add file name r dot. You need to give
Okay.
two different commands. Okay.
Okay.
Yeah.
Okay. Thank you.
Fine. Yeah. So everyone practice this so that you will understand. Okay. So you can create the GitHub account today or tomorrow morning. Okay. You can practice this. So tomorrow I'll show you once the code is pushed to GitHub, how can we pull back to local, right? So multiple times pushing, pulling. So developers always work on that. Okay. They push the code to remote repository. They pull the code from GitHub to local multiple times. Right, so I'll show you tomorrow, and also branching strategies will start tomorrow. Branching strategies, important one. Fine. Yeah, so we can stop here. So this weekend, 2-hour session will be there. So make sure everyone attend. Okay, fine. Yeah, thank you all. Branching strategies. Yeah, so what is branch? What are the importance of branch? What are the strategies we use? Okay, let's try to understand. So before going to discuss about branching strategies, let me quickly recap Git workflow. Yeah, so Git workflow, in Git workflow, we created workspace, right? First, we need to create workspace. When developer joined the project, they need to create one workspace, which is a local folder, right? Workspace is a local folder. In the local laptop or desktop, we need to create a folder, right? So local workspace, it is a space where we store our data, right? Yeah, so we create the workspace. After that, we need to initialize. Command here is git init. Git init is the command to initialize, right? Yeah, to initialize the local workspace. After that, immediately what we have to do? We need to create one user, right? Yeah, how to create the user? Command here is
Config global user dot name.
Yeah, git config space hyphen global
User dot name.
user dot name. Within the double quotes, we need to give the username. Yeah, after that, email ID also, right?
Yeah, git config fnf global user dot email.
Yeah. user
Making
dot.
records, we have to give our email ID.
Yeah. Fine. So here we need to create a user and email ID, right? So why we require user? Why we require email address, right? So this is mainly for tracking, right? Who did what? Yeah. So mainly for tracking. So if you want to check the existing user, what are the command we use?
Git config --- list.
Yeah, --- list is the command to check the existing user, right? So one workspace, one user only, one laptop, one user only, one desktop, one developer only, right? Yeah. So when you try to create one more user, if you create one more user, what will happen? Old user will be override, right? Yeah, that we discussed already. Yeah. So once we create the user, after that, development should be started, right? Developer start the development. VI, dev.txt or whatever. They create a file, they add data into the file, right? Like this. So once the development is completed, so here while developing is going on, if you check here, Git status, the file will show you in
red color.
Yeah, red color, right? So still development is going on. Still development is going on, right? Once the development is completed, the data should be moved to the
Staging area.
staging area. Staging area or index area, both are same.
Yes.
Yeah. Staging area, or we can say index area, right? Yeah. How can we move the data to staging area? What is the command we use?
Git
add, right?
file
Space,
name.
file
Space.
name,
Or
or
git add space dot.
dot also, right? So file name. So if you give file name, only the respective file will move to the staging area. If you give dot, what will happen? So
all the files.
Yeah, all the files, whatever the files are available, right? All the files
Yes.
will move to the staging area, right? So once the files are moved to staging area, if you check here, Git status again will show you in green color. Green. So green means development completed. Now it is ready to commit, right? Yeah. After that, what we can do? We can commit the code. So this is the next one is commit area. So this is commit area, or we can say Git local. Commit area, or we can say Git local, right? Yeah. So if you want to commit this code, the command here is Git commit
-m and message.
Yeah, -m. So we can say commit message, right?
Yes.
Commit message. So meaningful message we need to give here. Meaningful message, right? Yeah. So once we commit the code, now if you check here Git log, yeah, it will show you who did changes, when did changes, what purpose did changes. We can easily track. So once we commit the code, the tracking will be started, right? So
Yes.
once we commit the code, after that we can
Push
the code to
repo.
remote repository, right? Which is GitHub. GitHub, right? So if you want to move the code to GitHub, so very first thing we need to establish the connection between local and remote. After that, we need to push the code to remote repository, right? So to establish the connection between local and remote, command here is
Git remote add origin
Yeah.
the URL HTTP.
correct. Git remote add origin, remote repository, URL, right?
Yes.
Yeah. After that, if you want to push the code to GitHub, command here is
Git push -u origin master.
origin to master. Yes.
But Ram, when I created, it is asking for master, it didn't happen, but for main, it got success for me.
Okay. So main to master also you can change. Normally, so main or master both are same, nothing to worry.
Okay.
You can use the main or master.
Okay, so main is also correct, right? Because
Yeah.
it's showing default as main for me.
You can change main to master. Better you can use master. How to change main to master? You can search in Google. You will get the steps. Yeah, if it is not working, I'll show you tomorrow. Okay, nothing to worry.
Okay.
Yeah, so we can push the code to remote repository, right? So this is the way normally every developer, every tester, every team member, not tester, developers always they work on this same. They use the same flow, Git workflow, right? Yeah, fine. So today we are going to discuss about branching strategies. So first of all, what is branch? Let's try to understand. Branch is a division. Branch is a division, right? Branch is a division. So branch is a division. So normal in real-time projects. So for example, here, so currently we are using very advanced tools like Jenkins, Git, Jenkins, or GitHub Actions also fine. In place of Jenkins, we can use the GitHub Actions also, right? So Maven, Ansible, Docker, Kubernetes. So these are all very popular tools. These are all very popular tools. Kubernetes. Okay. So these are all very popular tools, right? Why these tools are very popular? Because of parallel development. Because of parallel development. What is parallel development? Okay. So currently we are working on Agile methodology. So we have two methodologies available, right? So waterfall, Agile. So currently we are not using waterfall. Every project team they're using Agile methodology, right? Agile is the parallel development. Agile is the parallel development, right? So one application development will be divided into bits and pieces. One application will be divided into bits and pieces. That bits and pieces we can call it as sprint. Sprint is a timeline. Sprint can be 1 week to 1 month, right? For example, one sprint started today. So by next Monday, EOD that should be completed. That is weekly sprint. Monthly sprints, for example, so today one sprint started on 14th July. Next month, 13th, EOD that should be completed. Sprint can be 1 week to 1 month. 1 week sprint, 2 week sprints, 3 week sprints, and 1 month sprints. Anything, right? Yeah. So in parallel development, these tools we use. If you want to perform the parallel development activities, so we use all the tools, right? Yeah. By using these tools, we can work on Agile methods. Fine. Now, for example, so when we talk about branching strategies, let us take small example here. Let us take small example here. Look at my screen, everyone. So for example, this is a bank. This is bank. HDFC Bank, for example. HDFC Bank. Okay, so this is we can say main branch. Main branch. So in banking terminology, main branch you can call it as zonal office. Zonal office. Main branch. Okay. Yeah, in this main branch, Saving accounts going on, saving accounts going on, current accounts going on, right? So credit cards going on, debit cards going on, and personal loans, home loans, consumer loans, right? And also, auto loans, car loans, bike loans, whatever, right? So all the activities going on one branch, single branch, right? Yeah, that is also fine. Currently, we are using online banking, but to improve the banking, they are increasing the branches. To improve the parallel banking, they are increasing branches. To improve the parallel banking, they are increasing branches, right? So HDFC Bank branches, so many branches are available across the globe, right? So to improve the parallel banking, they're increasing the branches, right? So here, for example, this is branch A and branch B. Branch A and branch B. Branch A, branch B. So once they create a branch, what will happen? Whatever the data is available on the main branch, that will be replicated to the branch A, right? So once they create new branch, whatever the data is available on the main branch, that will be replicated to the new branch automatically, right? So that on top of the latest data, they start working. On top of the latest data, they start working. They start the transitions. Okay. Once they add any new transitions, what they will do? They will merge to the main branch. Once they add any transitions, the transition should be merged to the master, main branch, which is main branch is a master branch. Master always maintain the latest data, right? So master always maintain the latest data because, for example, when you access the data, online banking, right? Like net banking. So we will get the latest updates, latest data, right? We'll access from main branch only, not sub branches. So when we log in net banking, we will access main branch only, not sub branches, because main branch always maintain the latest data, right? So here also same, second branch created here. So once we get the new branch, data will be replicated to the new branch here, right? So once they add any transitions, that should be merged to the main branch, right? So this is the process. Every banking people, they're following the same process. Every bank following. Same way in development environments. Okay. How can we perform the? How can we create the branches? How can we work on the branches? So what are the importance of branches? Let's try to understand. For example, this is main branch. We can say this is master branch. In development environment, there is a branch which is a master branch. This is master branch. Yeah. So master always maintain the latest data. Master always maintain the latest data, right? So in this master branch, there is a latest data, right? So now what I will do, I create a new branch which is development branch. Development branch. So once we create the new branch, what will happen? So whatever the latest data is available on the main branch, master branch, that will be replicated to the new branch, right? So on top of the latest data, development should be started. On top of the latest data, development should be started here. So here we create a sprint 1. Developers create a sprint 1. They start working on the sprint 1. Once they add any changes on the sprint 1, they need to merge into the master. Latest changes should be merged to the master, right? Yeah. So while working on sprint 1, so in the sprint 1, some hard fixes happened. Hard fixes. So development will not be stopped. Any hard fixes happen, issues happen, bugs happen, right? Any bugs, issues, right? Development will not be stopped. Okay. So here we create one more branch immediately. So this branch name is hotfix. This is hotfix branch. Yeah, in this hotfix branch, yeah, hotfix team, what they will do, they start working on. So once we create the hotfix branch, immediately latest data will be replicated from master to hotfix. Here development will be started, right? So once they add any changes on the hotfix, they need to merge into the master, because master always maintain the latest data, right? So while working on sprint 1, so we can create one more branch, which is we can say future release branch. This we can say sprint 2. This is future release branch. We can say this is sprint 2. Sprint 2. So once we get the sprint 2, what will happen? Latest data will be replicated from master to sprint 2, right? So in this latest data, development will be started, right? Once development is completed, or once they add any changes, that should be merged to the master, right? So this is the process. Every development team, they're following the same process. Okay. So here we are discussing about sprint 1, sprint 2, sprint 3, sprint 4. These sprints are sprint 1, sprint 2, sprint 3. So these sprints are, we can say, all these sprints are, we can say, development cycles. We can say development cycles. These are all, we can say, development cycles. Okay. Clear, right, everyone? Shall we move on? Practically, we can work on this, right? Any questions, anyone? You can ask me now. So far, any questions you can ask me before going to start working on branches. Fine. Let's move on. Yeah. I just create a workspace here. So branching, workspace name, open the workspace, right click here, show more options, click on Git bash here. Now here, Git init here, Git init to initialize empty Git repository. Now, when I initialize, what happened here? Look at my screen, everyone. Now it is showing something like master, right? So here, yeah, once we initialize, here it will show you the master branch. Master branch is the main branch, right? Now, what I will do, so in the master branch, I want to create a file here. vi master.txt, master.txt. Enter. Insert hi, this is master branch. Escape, save and quit. Right? So this is master branch. Okay. In the master branch, I created a file. So immediately what we have to do, we need to move to the staging area. Git add space dot, right? Once development is completed, the file should be moved to the staging area, right? Now the file is moved to staging area. Now if you check here Git status, we show you green color, right? Yeah, once we move to staging area, now we need to commit the code, right? So Git commit -m commit message, master changes, right? Now it is committed. Now if you check here Git log, it is showing who did changes, when did changes, what purpose did changes, right? So in the master branch, I have a data, I have a file, right? Now I want to create a development branch. I want to create a development branch. So how can we create the development branch? Let's try to understand. Okay. So command here is to create a new branch, git branch space branch name development. Enter. So development branch created here. Development branch created. Now, if you want to check the branches, how many branches are available? If you want to check, command here is git branch is the command to check the list of branches. Look at here, development branch and master branch. Okay. Now, currently I'm in master branch, right? So now I want to switch to the development branch. I want to switch to the development branch. So once we create the new branch, what will happen? We discussed already. Once we create the new branch, what will happen? What will happen? Once we create new branch, what will happen? Anyone?
What all the things are available in master branch, those things will come.
Exactly. Yes. So whatever the data is available on the master branch, that will be replicated to the new branch, right? So we created the development branch, right? In this development branch, latest changes are available. So currently here, if you check ls, master.txt available in the master branch. Now I want to switch to the development branch. How can we switch? Git checkout development. If you want to switch to the development branch, git checkout development. Now look at my screen, everyone. Now I'm in development branch. Now if you check here, ls, look at here, same file available, right? Whatever the file is available on master branch, same file available here, right? Now what I will do, I want to create a file inside of the development branch. Okay. So vi devo.txt insert hi, this is development branch. Escape, save and quit. Now git add space dot git commit -m commit message devo changes. Now the file is committed. Now if you check ls, so in development branch, how many files are there? 2 files, right? In master branch, how many files are there? Only 1 file, right? So whatever the changes happened on the new branch, that should be merged to the master branch, okay? Because master always maintain the latest data. So now what I will do, git checkout master. If you want to merge to master, first you need to check out master. In the master branch, now if you check ls, only 1 file is available. But whereas development branch, we have 2 files are available. Okay. So in the master branch, only 1 file is available, right? Now I want to merge development branch to master. How can we merge? Git merge development. I want to merge development branch to the master branch. Enter. Now here the file is dev.txt merged to the master. Now if you check ls, look at here, 2 files are available. Earlier only 1 file, now 2 files are available here. Clear, right, everyone? Yeah. So while working on development branch, okay, so we got some hot fixes, issues, right? So immediately what we can do, we can create one more branch, which is a hotfix branch. How can we create the hotfix branch? Now command here is git branch space branch name hotfix. Now the branch is created here. Now, if you want to check all the branches, git branch is the command. Look at here. Development branch, hotfix branch, master branch. 3 branches are available. So now, if I switch to the hotfix branch, how many files will be available on the hotfix? Anyone?
No file.
2 files.
Two.
2 files, right? Correct.
Files, 2 files. Dev and master.
Yes, whatever the data is available on the master, the same data will be available on the hotfix also, right? Now, git checkout hotfix. Now I'm in hotfix branch. Now, if you check ls, look at here, look at my screen, everyone. Dev.txt, master.txt, 2 files are available. So currently I'm in hotfix branch. Okay. Now I want to create a new file on the hotfix. Vi hotfix.txt. Insert hi, this is hotfix branch. Escape, save and quit. Now git add space dot git commit -m commit versus hotfix changes. So every time we need to move to the staging area, we need to commit the code, right? Now, if you check here, ls, look at here. In the hotfix branch, how many files are available? We have 3 files available. But whereas master, how many files are available? Master is having 2 files, right? So we need to merge hotfix to the master. How can we merge?
Git merge hotfix.
We need to check out to the master first, right?
Yes.
Check out to the master. Now, if you check ls, only 2 files are available in the master. Now, I want to merge hotfix to the master, right? So, command here is git merge hotfix. Now, hotfix merge to the master. Now, if you check ls, look at my screen, everyone. Dev.txt, hotfix.txt, master.txt. So, whatever the data is available on the master, that is the latest data, right? So every branch, when we create the new branch, the data will be replicated to the new branch. Fine. Yeah. So this is the way in real-time projects we can create the branches. Developers always create the branches. They work on the branches, right? Now, same way. So whatever the branch is created here, same way we can create the branches in GitHub also. Whatever the branches we created in the Git, right? Same way we can create the branches in GitHub also. How can we create the branches in GitHub? Let's try to understand. So GitHub is GUI, right? It's very simple, very easy to create the branches in GitHub. It's very simple. GitHub.com, go to GitHub.com. Yeah, 114 repository, right? Yeah, this is our repository. Click on this. Yeah, this is the file. Yesterday we pushed to the GitHub, right? So currently we have only one branch, which is a master branch. Look at my screen, everyone. Only one branch. Now I want to create a new branch. I want to create a new branch. How can we create a new branch? So click on this drop down. Click on this drop down. Now here you can create a new branch. Branch name development. I want to create a branch name development. Click on create branch development from master. Click on this. Yeah. Now development branch is created here. And once the branch is created, so automatically the data replicate to the development branch. Whatever the data is already available on the master, that data replicated automatically. Look at here. The data automatically replicate to the development branch. In the master branch, we have a file which is git.txt, right? Same file replicate to the development branch also. Clear, right, everyone? Now I want to add one more file here. Click on plus symbol. Create new file. File name, whatever the name you want to give, we can give. File name, so dev.txt. Okay. So I do something here. Okay. File here. Dev.txt. This is development. Okay. Click on commit changes. Click on commit changes. So here commit message, if you want to give, you can give, or else click on commit changes. Yeah. Now look at my screen, everyone. In the development branch, 2 files are available. In the development branch, we have 2 files available. But whereas master branch, only 1 file is available. In the master branch, only 1 file is available. In development branch, we have 2 files available. Right? Yeah. Now, whatever the latest data added to the development branch, that should be merged to the master branch. Latest data, whatever the latest data is available on the, whatever the latest data added to the new branch, that should be merged to the master, right? How can we merge? Yeah, here it is showing something like development had recent pushes 19 seconds ago. Development branch is having latest changes. That should be compare and pull request. That should be merged to the master, for which we need to compare and pull request. Click on compare and pull request. Yeah, now create pull request. Merge pull request. Confirm merge. Done. Done. It is merged. It is merged. Okay. Now what we can do here, go back. Go back here. Look at my screen, everyone. So in the master branch, how many files are available? Dev.txt, Git.txt. In development branch, same data available. Same files are available. Right? Now, what I will do, I want to create a one more branch. I want to create a one more branch, right? How can we create new branch? Click here. Now give the name, branch name, hotfix branch, hotfix, just hotfix. Create a branch. Create branch. Now the branch is created here. The data is replicated to the hotfix branch. Latest data replicate to the hotfix, right? Now, instead of this hotfix branch, I want to add one more file. Click plus symbol, click on create new file. Now, give the file name hotfix. Yeah, this is hotfix branch. Click on commit changes. Commit changes. Now look at my screen, everyone. So hotfix is having latest changes, latest pushes, right? So hotfix.txt available. Here hotfix file is available, right? But the master is having only 2 files, dev.txt, git.txt. But whereas hotfix is having 3 files, right? So extra file is available, hotfix file. That should be merged to the master. How can we merge? Click on compare and pull request. Create pull request. Merge pull request and confirm merge. Now it is confirmed. Now it is confirmed. Clear, right, everyone? Now look at here. Look at my screen, everyone. So hotfix file is available in the master branch, right? So this is the way in GitHub also. We can create a branch. We can merge the branch. But in real-time projects, we should not develop any code on GitHub. We should not add any files in the GitHub, right? But for example, so for understanding, I created a file. I created 2 files here. But in real-time projects, we means developers. Developers always work on local Git. Developers always work on local Git, right? They push the code to GitHub. They work on local Git. They push the code to GitHub. Clear, right, everyone? Yeah. Any questions so far, anyone? Yeah, Abhay, ask your question.
Yes, Sam. So, whenever we are clicking on the pull request, it should be related to some sort of rule, right? Because it's a development branch and it is going to merge with the master. So, some specific person has to merge it. It is not like that. Normally, we can just click on the merge pull request and merge it.
Exactly. Yes. Good question. Explain that. Okay, wait for 1 minute. So, any other questions, anyone?
Can you go to development branch here? Master to development.
Yes. Click on development. 2 files. In development, only 2 files.
But 3 need to come, right? Now currently master is having 3 files.
Yes. Master is having 3 files, but development is having only 2 files. Okay. So how can we get the latest data from master to development? I'll show you after 2 sessions. Wait for 1 or 2 sessions. Okay.
Yeah.
There is a rebase concept. In that concept, you'll understand.
Okay, Ram. Thank you.
Yeah. Fine. So Abhay asked the question that, okay, so pull request, normally developers, they should not merge. Yes, that is true. In real-time projects, pull request will be raised by developers. That lead should be approved. Lead should be approved. So whenever you want to merge, it will not be allowed. So normally in real-time environments, in private repositories, yeah, pull request, when you want to merge, you need to get approval from lead. Once you click on pull request, that request will go to the lead. They will check it out. They will verify the data. So they will approve. Then only we can merge. Otherwise, what will happen? So 3 developers working or 4 developers are working. They are doing some activities. They can merge easily, right? Bugs will be increased. That is why, so before going to merge, lead should be approved. Right? So once the lead approved, then only we can merge the code to the master. Hope you understand, Abhay. Everyone understand? That option,
Yes.
yeah, that will be happen in private repository. But in public repository, we can merge. Whenever you want to merge, you can merge. But in private repositories, pull request is very, very important. So once we raise a request, lead verify the data and they approve for merging. Then only you can merge. Fine? Yeah. Now, next concept, important one. So any developer, new developer join into the project. As a DevOps engineer, we need to give the KT. And we need to share the GitHub repository URL and we need to explain the process as a DevOps engineer. So once we explain the process, they start the development. Right? Yeah. So now, for example, new developer joined the project. Once new developer joined the project, we give KT. What is KT and anyone?
Knowledge training.
Yeah, knowledge
transfer.
transfer, right? Yeah. So in the KT, we need to explain 5 important points. 4 to 5 important points. First one here is create a workspace. That is the first point. Second point here is initialize Git init. Right? So after that, third one. Yeah, in real-time projects, we don't need to create a user. Because we always use the LDAP user. We use LDAP user. What is LDAP user? What is LDAP and anyone?
Lightweight directory access
Lightweight
protocol.
directory access protocol.
Yeah, lightweight directory access protocol, right? So use the LDAP user. We need to tell them use LDAP user. Okay. Yeah. After that, fourth one, share GitHub repo URL. Share GitHub repo URL. So after that, fifth point here is start development. Before that, pull latest data from GitHub. Pull latest data from GitHub. And the sixth point here is start development. So these are the 6 important points we need to explain. So how to pull the data? How can we move to staging area? How can we commit the code? That we don't need to worry about. Just a moment, please. Fine. Yeah, so these are the important 6 points we need to follow, developer should follow, right? Yeah, developers, they never follow the process. So they will not follow the process, so that they will get so many issues, errors that I'll show you tomorrow. Okay. Yeah. So we gave the KT. So this KT we gave, right? So now new developer joined the project. Okay. So he created the, as per the KT, he started the development. So he created the workspace, local workspace. He created the workspace. Now you open the Git bash here. Git init here. Now, very first thing you need to establish the connection between local and remote. So we already share the remote repository URL. So you need to establish the connection between local and remote, right? So git remote add origin space remote repository URL. Go to GitHub account. So here there is a code, right? Click on this. This is the URL. Copy this URL. Click on the copy symbol here. So code, click on drop down, copy this GitHub URL, go back here, paste here. Enter. So connection established, right? Now you need to pull the latest code from remote to local. Git pull origin to master. So yeah, in the last session, we pushed the code to GitHub, right? Git push origin to master. Now I want to pull the code from GitHub to local, for which git pull origin master. Now the code is pulling into my local. Yes. Now it is pulled. Now if you check ls, look at here. 3 files are available. Whatever the data is available on the GitHub. Look at here, 3 files, right? Same data I pulled into my local, right? So on top of this latest data, development should be started, right? Now vi code.txt. Insert I, this is my new application development. Escape, save and quit. Now git add space dot git commit -m commit message, new development. Now git push -u origin to master. Now I want to push this file to the GitHub. Enter. Now the code is pushed to remote repository. Now if you refresh here, code.txt. Look at my screen, everyone. Code.txt just now, right? So this is the actual process every development team follow. Every developer should follow. But the developers, they never follow the process. They will get so many conflicts, so many issues, right? So tomorrow I'll show you 4 real-time challenges, important challenges. So interview questions also. 4 real-time important challenges, interview questions also, right? So after that, we'll discuss about Git conflicts, one more concept. So 4 real-time challenges. Git stash, one more concept is there. Git stash, stashing. After that, we'll discuss about Git conflicts. So tomorrow, 3 concepts. Real-time challenges.
Git fork also, right?
That I'll show you later. Yes, day after tomorrow.
Okay.
Forking also fine. Forking very important. I'll show you that. Okay. So here, look at my screen, everyone. It's showing fork, right? How can we fork? I'll show you. Wait for some time. Okay. Yeah. So far, any questions, anyone? So far, any questions, anyone? So make sure everyone practice these concepts and you will get interview questions here. Okay. Tomorrow I'll show you 4 interview questions. Very important interview questions. Every interviewer asking that questions. Even last interview, one of the student, so 112 batch student, right? She cracked the interview a few days back. Okay, so he got the questions, Git questions. So 4 interview questions, which are very, very important, right? In Git, maximum 8 questions I'll give you. In that, damn sure you'll get 2 or 3 questions. So maximum 2 or 3 questions only on Git, they will ask. I give you 8 to 10 questions, in which you will get only 2 or 3 questions. That's it. Those are enough to you. Okay, fine. Yeah, so make sure everyone practice this Git workflow and branching strategies. Yeah, go ahead, please. You're asking something.
Yeah, yes. So this yesterday and today, right? You showed us sample text files for understanding this.
Yes.
Yeah, may I know what all the languages Git is supporting?
Any language, HTML, CSS, Java, Python, Ruby, Perl, any language. I'll show you real code once we start working on Jenkins. I'll show you real code. Real code is there with me. Java code is there, and .NET code is there, HTML code is there. I'll show you. So for understanding, we are creating the files, normal text files. But actually, in real-time projects, we push real code, right? We means developers. Developer push real code. That I'll show you while working on Jenkins. Okay.
Okay.
So that code we can deploy while working on CI/CD project. We can deploy the code. How can we deploy that? We'll see that. Okay. Fine. Yeah. So today's session and yesterday's session, both are very, very important sessions. Make sure everyone practice these 2 sessions so that you will understand tomorrow's session. Okay. So Git is not our tool, not like that, right? Don't take light. Okay. So definitely you'll get interview questions. You'll get scenario-based questions also in Git. That is why you need to practice. If you practice these 2 concepts, you'll get a very good confidence. Okay. So Git maximum 5 sessions only, right? But entire DevOps we use the Git, right? So we need to understand the process. We need to understand the concepts here. Fine. Yeah. So make sure everyone practice these 2 sessions. And tomorrow we'll discuss about real-time challenges, 4 real-time challenges, Git stashing, Git conflicts, 3 concepts. After that, we'll jump into a Git Rebase, Cherry Pick, and also we have a difference between Git and SVN. Right. After that, we have Git Tags, Git fork, Git clone. Different concepts are there. Fine. Yeah, so you can practice these 2 sessions. So if you have any questions, you can take down. We'll discuss tomorrow. Fine? Yeah.
Ram, one more last question.
Yeah. Go ahead, please.
Yeah, for creating the user, right? Real time, you mentioned LDAP, but currently we are organizations are using SSO also, right?
SSO, yeah, single sign-on.
Yeah.
Normal single sign-on is mainly for to log into the apps, right? Applications.
Yeah. That is all centralized access.
Yeah. Once you log in SSO, it will take care of all the logins, right?
Yes.
Yeah. So that is for login only. But here LDAP user is alias account. Once we join into the project, we'll get one user and email ID, right? That alias user we use it. Okay. Real-time process. Fine.
Thank you.
Yeah. So we can stop here. So make sure everyone practice and very, very important concepts. Fine. Yeah. Thank you all. Can you see my screen, everyone? Can you hear me? Am I audible?
Yes, Ram.
Yeah. Fine. So in the last session, what we discussed? About
branch strategies.
Yeah, branching strategies, right? Yeah, branching strategies. Okay. Yeah. What is branch? Why we require branch? Why the project teams are looking for branches, different branches, right? So what are the importance of branches? These are all we discussed, right? Yeah. So how to create branch? How can we merge the branch? How can we switch to the branch? How can we change the branch? These are all we discussed, right? So anyone having any questions so far on branching strategies? Anyone having any questions?
I have noticed that from the master branch is there, right?
Yes.
From master branch, if you are creating any new branch, those all files are coming into new branch.
Yes. By default, yes.
Yeah, but I have tried in a different way. I have created development branch. From development branch, I have created test branch.
Okay.
When I created a test branch, what all the files are available in development branch, those are also came into test branch.
Yes, that is true. But normally, master always maintain the latest data, right?
Yeah.
Master always maintain the latest data. We need to create a branch, new branch from master only. That is thumb rule.
Okay. I thought only from master only we can inherit all those.
Yeah.
Okay, thanks.
Yeah. Any other questions, anyone? Any other questions, anyone? Fine. Yeah. So yesterday we discussed about one more concept, which is when developer join into the project, how can we give the KT to the developer? How they need to start the development, right? How they pull the code into local from remote repository, and on top of the latest code, how they need to develop the code. So these are all we discussed, right? Yeah. Today we are going to discuss about 4 real-time scenarios. First, 4 real-time scenarios. Four real-time scenarios. After that, we have different concepts: Git stashing, Git conflicts. Okay. Yeah. So in which 4 real-time scenarios? First one we already discussed. I just want to recap that quickly. Yeah. First scenario already discussed in the last session, which is when developer join into the project, how to give the KT, how they need to pull the code, how they need to start the development. So we already discussed. That is first scenario. I just want to recap quickly. Right, we need to give the KT, right? So KT should be, we need to give the KT. So once we give the KT, they need to start the development, right? Yeah. So scenario 1, Scenario 1. Yeah, how developers start the development. Scenario 1, how developers start the development. Let's try to understand. Okay, quickly, I just want to recap because 4 real-time scenarios which are very, very important. First one is properly developers start the development. Okay. Second scenario, third scenario, fourth scenario, they do mistakes, right? How can we check them? How can we find out the mistakes? How can we guide them? Okay, we'll see that. Fine. First scenario, when developer joined the project, we gave KT and we gave the GitHub repository URL, right? We explained the process. They started the development. Okay, I just want to recap quickly. So create one workspace here. Create a workspace. Scenario 1. Scenario 1. Open the workspace. In this workspace, open Git Bash here. Git init here. Initialize. So after that, you need to pull the code from remote to local, latest code. User, we don't need to create in real-time projects because we always use the LDAP user, lightweight directory access protocol user, right? Alias account when we join into the project. So yeah, we'll get the user ID and also we get the email ID, right? We'll get the alias account, user account, and also email account. By using that, we can log in all the consoles, right? Yeah. So very first thing, what we have to do, once we initialize, after that, we need to pull the latest code from remote to local, right? For which command here is git remote add origin. Remote add origin. Go back to GitHub account. (114). Open this. Yeah. So this is our repository, right? So yeah, copy the repository URL here. Copy this. Now go back here, paste here. So git remote add origin remote repository URL. Enter. Now connection is established between local and remote, right? So now I want to pull the code from GitHub to local. For which, what is the command we used? Anyone? What is the command we used?
Git pull origin master.
Yeah, git pull origin to master. Yeah, now the code is pulling. Yes. This is the code, right? Now, on top of this latest code, developer start the development. vi code 1.txt insert hi. This is a new development. Escape, save and quit. Git add space dot git commit -m commit message. New development. Yeah, now the code is committed. So after that, we need to push the code to GitHub. For which command here is, what is the command we use?
Git push -u origin master.
Yeah, git push -u origin to master. Origin is the variable, right? Now the code is pushed. Yes, successfully pushed. Okay. Now go and refresh here in the GitHub. Code 1.txt. Look at my screen, everyone. This is the latest code, right? So not really, it is a real code, it is a text file. Okay. So while working on, once we start working on Jenkins, I'll show you real code. Fine. So this is fine. So scenario 1 is clear, right? Scenario 1 is properly developer start the development, right? But second scenario is very, very important. Interview question also, right? Yeah. So same way, second developer joined the project. We gave the KT, right? But what he's doing? So let's try to understand. Scenario 2. Git bash here. Git init here. Yeah. Once we initialize, now, once create the workspace, after that initialize the local repository. After that, so without pulling the latest code from remote to local, he started the development. That is a major mistake. Okay, developers always do this mistake. Okay, so very first thing, you need to establish the connection between local and remote, and you need to pull the code from remote to local. So on top of that only, you need to start the development. So without pulling the latest code from remote to local, you started the development, right? vi code2.txt. Insert not pulled the code. Escape, save and quit. Right? So it did not pull the code, he started the development. Okay, after that, is adding into staging, git add space dot git commit -m commit message. Commit message not pull the code. Right? Yeah. So once you commit the code, now he's trying to push the code to remote repository. Okay, for which is establishing the connection between local and remote, for which git remote add origin remote repository URL. Now the connection establishment is doing the connection establishment. Connection is established. Now it's trying to push the code to GitHub. Git push -u origin to master. What happened? Rejected, failed to push some references to remote repository. Updates were rejected because the remote contain work that you do not have locally. Updates were rejected because the remote contain work that you do not have locally. So remote work, GitHub account, GitHub repository work is not having in your local. That is why it is rejected. That is why it is rejected. Okay. Yeah. So in this case, what will happen? Developers, what they will do? They directly call you, mail you, unable to push the code to GitHub from local. So in this case, what we have to do? So what is the error you are facing? We need to ask them. We need to reply to the email, or we need to tell them. Okay. So they will send a screenshot. This is the screenshot. So unable to push the code from local to remote. Rejected, error, failed to push some references to remote repository. Updates were rejected because the remote contain work that you do not have locally. In this case, what we need to tell? So first you need to initialize. So immediately you need to establish the connection between local and remote. So you need to pull the latest code from remote to local. So on top of that only, you need to start the development. Because, you already having, without latest code, you already generated one committed. That will not be accepted by GitHub, right? So first of all, every developer should pull the code from GitHub to local. On top of that only, they need to start the development. That is a thumb rule, right? Yeah. So interviewer asks you, so one of our developers is unable to push the code from local to remote. What could be the reason? They will ask you. So we need to ask that interviewer, so what the error is facing? So updates were rejected because the remote contain work that you do not have locally. So is getting fast forward error. Okay. So simply you can tell them, is not having latest code in his local. First you need to pull the latest code from remote to local. So on top of that only you need to start the development. Without latest code, so if you develop the code, if you commit the code, so when you try to push the code to remote repository, you will get the fast forward errors. Clear, right, everyone? This is a mandatory question. Most of the interviewers asking this question. Okay. Yeah. So make sure everyone practice this. So this is an important question. Clear, right, everyone?
Ram, one question.
Yeah.
So the code.to text, if the latest commit is happened, so if you not pull the code, then we are getting error. If the nothing got changed, then we have already the latest code. Then if you not pull the code and if you do the development, there will be no error, right?
Yeah, already having code, nothing will be happen. Yes.
So the thing is, if the code is laterally committed or not, if the committed is happened, then the pull should happen. Am I right, Ram?
No. First of commit ID generated without pulling the latest code. So, for example, developer started the development. He pulled the code from latest. He pulled the latest code from remote to local, right?
Okay. Yes.
On top of the development, it started the development. He added new files, commit the code, push the code to GitHub. That will work. So without commit, how can you pull? Commit is mandatory. Commit is mandatory. Staging is mandatory. Latest code is also mandatory.
Okay.
Clear, right?
Yes. Ram, one more question. If the same file, the two, there is a two user story or a defect is there. So two person want to modify that particular file. So such cases, how this development will happen and the final merge and commit will happen, Ram?
So not 2 developers, 10 developers also, they can modify the file. That I'll show you, wait for some time. So in the Git conflicts, there is a concept. Git Rebase is the concept. 2 concepts are there. In that you will understand. Okay. Wait for one session. So definitely tomorrow I'll explain that. Okay.
Okay.
Multiple developers, when they modify the files, what will happen? I'll show you tomorrow. Okay. Fine. Yeah. This is second scenario, which is very, very important scenario. Next one, third scenario.
Ram,
Yeah, go ahead. Yes.
so one doubt is suppose that I'm a developer and I have pulled the code and I have modified one file, the same thing like code.txt, and I wanted to push that to the central repository GitHub only. Now, before pushing it, when I pulled the content or the code from the GitHub, by that time there was no change. But after pulling from the GitHub, there was some change happened. Now, if I push the code, will there be an error? Should I repeat the question?
Nothing. Yeah, understand the question. Okay. So normally, pushing, pulling multiple times, that will be happen. That is fine. But
In between,
finally,
GitHub is getting updated.
Yes. Finally, master should be updated. Master code, master branch. Okay. That is pull request. So multiple times developers pull the code, push the code, change the code, right? So finally, they merge the code to master. That is most important. Okay.
No, Ram, that was not my question. My question was,
Go ahead. Ask a question.
my question is, suppose that I have pulled the code from the GitHub master branch. Now
Right.
I have started development. Meanwhile, what happened in the GitHub master branch is updated by someone. Now
Okay.
at my repository, what I have pulled was a stale. It's old, right? Now currently the GitHub is updated in the master branch.
Right.
Now, with this scenario, what you have done is we have shown the error. Since we are not having an up-to-date code from the master, that is why this error was thrown, right?
No. Not like that. So, once you, for example, 4 developers are there, 4 or 3 developers are there. One developer pulled the code from master to local. He started the development. Second developer, he pushed the code to master. Second developer already is working on some application development. He pushed the latest updates to master. First developer, he will not get any errors. No need to pull the latest one. Nothing to worry.
Then in that case, he will be able to push his change also. First developer can also.
Yes. Right.
So it means that the basic skeleton and the file name should be there at the local wherever the developers are working.
Yes, correct. Yes. Fine. Yeah. So third scenario, which is very important one. Okay, so here, create a workspace here. Third developer joined the project. We gave the KT. He started development. So he's, yeah, open Git bash here. Git init here. Yeah, initialize. Right. After that, it did not pull the code from remote to local. He started development. Okay. VI code3.txt. Insert not pulled the code. Not pull the code. Escape, save, and quit. Right. So now is adding into staging. Git add space dot Git commit -m commit message. Not pull the code. Now, yeah, he added to staging, he committed the code. Now, if you check here, Git log, look at my screen, everyone. There is a commit ID generated in his local. He did not pull the latest code from remote to local. He started the development. Now he's having one commit ID. He's having a commit ID in his local. Now he's trying to pull the code from latest code from remote to local. Understanding that, everyone? In second scenario, he was trying to push the code. In third scenario, so now he's trying to pull the code once he generated the commit ID in his local. Right? Now he's trying to pull the code. What will happen? We'll see that. Okay. Yeah. So git pull origin. Before that, what we have to do? Before pulling the code, what we need to do? Connection establishment.
Git add what is master.
Yeah, now the connection is established, right? Now he's trying to pull the code. So he's already having a file which is a code3.txt, and also is having one commit ID. Right? Now he's trying to pull the code from GitHub to local, for which what will is executing the command. What will happen? We'll see that. Okay. Git pull origin to master. Now look at my screen, everyone. Yeah. So here is getting fatal error. Refusing to merge unrelated histories. Refusing to merge unrelated histories. What does it mean? Is having already one commit ID. With that commit ID, whatever the code is available in GitHub, that is it is unable to merge, right? So refusing to merge unrelated histories. Unrelated histories means already one commit ID is there in his local. Now, if you check ls, only one file is there. Is getting fatal error. Right? So in this case, developers, they call you, they mail you, right? They ping you in the Teams, unable to pull the code from remote to local. Can you check it out? They will ask you. So what the error you are facing? We need to ask them. So they will tell you clearly, fatal error, refusing to merge unrelated histories. In this case, what we need to do? What they need to do? What we need to tell? So first you need to pull the latest code from remote to local. So on top of that only, you need to start the development. Without pulling the latest code, so if you start the development, so once you commit the code, so if you try to pull the code from remote to local, you'll get the fatal error. That we need to explain. And also, interviewer asks you, one of our developers is unable to pull the code from remote to local. So what could be the reason? We need to ask them what the error is facing. Fatal error, refusing to merge unrelated histories. In this case, yeah, they need to pull the latest code from remote to local. So on top of that only, they need to start the development. Clear, right? So second scenario, third scenario difference, you understand, right, everyone? Is it clear to you, everyone? Yeah. One more scenario, which is very, very important. Anyone having any questions here? Right. So next scenario, which is fourth one. Yeah. Same way we gave the KT, new developer joined the project, fourth one. We gave KT. Now we started the development. Okay, so we gave KT and we provided the URL, remote repository URL, everything. So they started the development here. Okay, so here, git init first, git init, initialize. Now it is initialized successfully, right? After that, so without pulling the latest code from remote to local, without latest code, he started the development. Okay, vi code5.txt. Yeah, so not insert, not pull the escape, save and quit, right? Yeah, so without the latest code, without pulling the latest code, he started the development, right? So he added one file here, added a file, right? Once he add the file, he realized that, okay, first I need to pull the latest code from remote to local, then only I need to start the development. He added a file, right? So now he realized that, okay, I need to pull the code from remote to local. So on top of that only, I need to start the development. So Git always check the commit IDs. Git always check the commit IDs, right? So now is establishing the connection. Is establishing the connection. So Git remote add origin remote repository URL. Yeah, connection established. Now he's trying to pull the code from remote to local. Can he pull the code or not? Anyone?
No.
No.
No, right? Yeah. Who is this? Abhay?
Yes. Yes.
Yeah. Any other answers? Anyone?
No only.
Harshit?
No only.
No. Okay. Any other answers? Anyone? Yeah. So what we are discussing here, Git always check the commit IDs, I told, right? So developer started the development, initialized. After that, he created a file. So after that, he realized that, okay, so first of all, I need to pull the latest code from remote to local, for which he established the connection between local and remote. So after that, he's trying to pull the code from remote to local. In this case, what will happen? Code will be pulled without any issues because there is no commit IDs. Understanding, right, everyone? In his local, there is no commit ID, right? There is no commit ID. Look at my screen, everyone. Git log. Git always check the commit IDs. Git always check the commit IDs. No commit IDs here. Nothing. That is why code can be, we can pull the code easily without any issues. Simply can pull the code, right? So now git pull origin to master. The code is pulling. No errors, nothing. Code is pulled. You check ls, look at here. So all the files, whatever the files are available in GitHub, all the files are pulled into my local. Clear, right, everyone? Yeah, code 5 already there, right? File. Okay. This is a new file, not the old one. This is a new file, whatever we created here. Now what we can do here? Now what we can do? We can add into staging. We can commit the code. We can push the code to remote repository. Right? Yeah. So here, git add space dot git commit -m commit message scenario 4. Now git push -u origin to master. Now the code is pushing without any errors. Now go and check in the GitHub. Refresh here. Code file.txt. Look at my screen, everyone. Latest one. Right? So interviewer asks you this question also. This question also very, very important interview question. So one of our developers started the development. So is trying to pull the code from remote to local. Without latest code, he started the development. So once he started the development, he was trying to pull the code from remote to local. Can he pull or not? He will ask you. We need to ask them a reverse question, which is the developer is having any commit IDs in his local or not. No commit IDs, right? Then he can pull the code. If he's having any, so already committed, any commit IDs are available in his local, so code will not be pulled, right? Yeah, that is the difference here. Okay, so these are the 4 important scenarios which are very, very important. Okay, yeah, second, third, fourth, 3 are very important. Enter questions. Clear, right? Difference understand, right, everyone? These 3 scenarios difference you understand, right, everyone? Any confusions, anyone? Any confusions, anyone? Yeah, you can go through the recording one more time. So if you have any confusions, you will understand. Okay. Yeah. Next concept will move on. So these 3 scenarios are very, very important. First one, without latest code, he pulled the code into local. Second scenario I'm talking about. Without latest code, without pulling the latest code, he started the development. He was trying to push the code to remote repository. So for which he got some errors, issues, fast forward errors. In that case, first you need to pull the latest code from remote to local. So on top of that only you need to start the development. Second scenario, without pulling the latest code, he started the development. He already committed the code. So after that, he was trying to pull the code from remote to local. In that case, you will get fatal error, refusing to merge unrelated histories. Okay. So the fourth scenario, yeah. So without pulling the latest code into local, he started the development. He just added the file. No commits, nothing. Then he can pull the code from remote to local. Right? These are the very, very important scenarios, interview questions. Fine? Yeah. Next one. Git stashing. There is a concept which is a Git stashing. What is stashing? What is the importance of stashing? Let's try to understand. Stashing. What is stashing? Let's try to understand. Yeah. So for example, yeah, one of the developer is working on the application development, right? So 50% of the development completed. 50% of the development completed, right? So he spent already 10 days time, right? So without using AI tools, he is developing the application. Normally, by using AI tools, we can complete the development within 1 day, within 1 week also, within maximum 1 week. So by using Cloud Code, we can complete the development. So we don't need to learn coding part. right? So Claude, using Claude AI, we can get all the code. We can develop all the code, Python code or whatever. Okay. Yeah. End of the session, if possible, I'll show you how to get the code by using Claude. Okay. Not end of the session, end of the course while working on AI tools. Okay. Fine. So 50% of the development completed here. He spent 2 weeks time, for example. He spent 2 weeks time, 50% of the development completed. Middle of the development, manager came and gave the new requirement. Middle of the development, manager came and he gave the new requirement, right? Yeah. So already some development is going on. So again, if we start any new requirement, some mix and match will be happen. Mix and match will be happen. That is why here two things. First one is you need to complete the existing activity. Complete the existing development activity, right? So then only once you complete the existing activity, then only you need to take the new requirement. Second scenario here is you need to roll back the first activity, entire activity, then only can take the new requirement. Two things, right? So first you need to complete the first development activity, existing one. You need to take the new requirement. Otherwise, so second activity, important activity, for example, second one is very important, very urgent activity, for example. So in that case, what they need to do? What you need to do? You need to roll back the first activity and you need to execute the second activity. Here we have two scenarios only, right? So these are the two important scenarios. Yeah, without completing the first activity, without rollback the first activity, how can he start working on the second activity, which is nothing but stashing. By using stashing, we can achieve this requirement. By using stashing, we can achieve the requirement without disturbing the first activity. So he can execute the second activity. He can complete the second activity. So after that, he can resume the first requirement, first activity by using stash. Clear, right, everyone? So what is stash? You understand it? One of the developers working on application development, right? So 50% of the development completed. Manager came and gave the new requirement. So in that case, by using stashing, he can hold the first activity. He can complete the second activity. He can start working on second activity and he can deliver the second activity. So after that, he can resume the first activity. Right? This is very, very important. So every developer using the stashing currently. Fine. Now, yeah, stash is the workspace. Git bash here. Okay. Now, vi file.txt. Okay. Enter. Insert. Hi, this is stash testing. Escape, save and quit. Right? Now, git add space dot git commit -m commit versus stash. So once we commit the code, again we can edit the code. Once we commit the code, again we can edit the code if you want to edit. Vi file.txt. So here insert something like a new change. Escape, save and quit. Right? Now if you check here git status, now the file What happened? Not Git. Okay. What is the mistake here we did? Any guess?
Git init we have not used.
Yes, correct. First we need to initialize, right? Initialize. Branch required here. So without branch, how can we work? Master required, right? Yeah. Now, vi file.txt. Add space dot commit hyphen message. Again vi file.txt. Insert. Right. Now, if you check here Git status, now the file is showing red color. Means still development is going on. So 50% of the development completed already. 50% of development completed, right? So now manager came and gave the new requirement. So for example, he spent 2 weeks time. Just imagine that. Okay, so manager came and gave the new requirement. So in this case, how can we achieve this? How can we, without disturbing the first requirement, how can we achieve the new requirement? It's very, very important. Okay. Yeah. So whatever the existing activity already there, that activity we need to stash first. Stash means hold, freeze. Stash means freeze, hold. That we need to hold first. Once we hold that, we can start working on the new requirement. Once we complete the new requirement, again go back and resume the previous requirement. Clear, and everyone? Is it clear to you, everyone? Yeah. Now let's try to understand. Practically, we can execute this. Okay. Yeah. So now I want to stash this first. This file, whatever the data is available already here, that we need to stash first. How can we stash? Yeah. So command here is git stash. Git stash is the command. To stash the existing activity, we need to give the git stash is the command. Git space stash. Enter. Now it is stash. Now it is stash. If you check here, now, if you check here git status, nothing is there. Nothing to commit. Working tree clean. But this is available inside of the local workspace. On master branch, nothing is there, right? But it is available. It is freezed. Stash. Now we can take the new requirement. vi stash.txt. Insert this is stashing. Escape, save and quit. Right? Now if you check here git status, now it is showing only stash.txt is in progress. Right? So once he complete this new requirement, he can add into staging git add space dot git commit -m commit message stashing. Now it is committed. Now we can push the code to remote repository. Once the code is committed, from here it will move to the GitHub remote repository. Clear, right, everyone? Yeah. So once it is completed, once the code is completed, once the latest one, a new requirement completed, you can go and resume the previous activity. You can go and resume the previous requirement. How can we resume that? Yeah, so the command here is, so currently if you check here git status, nothing is there. Now we can resume the previous requirement, old one. How can we resume that? Git stash space pop, POP pop. Git stash space pop, POP pop. To resume the old requirement, previous requirement. Enter. Now file.txt available. Now if you check here, Git status. Now it is showing file.txt available. Okay. So now what we can do, we can add into staging. Once the development is completed, once the 50% remaining development completed, git add space dot git commit -m commit message. Now the code is committed. From here, it will move to the remote repository. From remote repository, Jenkins take the code, it will deploy onto respective target servers. Clear, right, everyone? Is it clear to you, everyone?
If we are having multiple files, that time also same?
Yes, same process. Same process.
Okay.
Stashing concept, you understand, right, everyone? What is stashing, you understand, right, everyone? Yeah, fine. Now, I'll show you some GitHub settings, okay? So still we have 10 minutes time. So if I start conflicts concept, it will take nearly 20 minutes, okay? So better we can go and work on GitHub. I'll show you some GitHub settings. Okay? Yeah, so for example, currently we are using master branch as a primary branch, default branch. Understand that, everyone? So master branch as a default branch. If you want to change development branch as default branch, you can change as per the requirement. As per the requirement, if you want to use the development branch as a default branch, you can change. How can we change? Look at my screen, everyone. Okay. So go back here. Go to settings. Click on branches. Yeah. Now, just a moment. Look at my screen, everyone. So, yeah, go to settings. Now it is showing here default branch is master branch. Now I want to change development branch as default branch, for which click on this symbol, switch to another branch. Click here. Yeah, now we can update here. In place of master, you can view development. Click on update. I understand, update the default branch. Yes. Now look at my screen, everyone. So now the default branch is development branch. Go back here. Now look at my screen, everyone. Development branch is the default branch. Now it is asking something like compare and pull request. Why it is asking compare and pull request? Because default branch required latest data. That is what it is asking compare and pull request. So click on compare and pull request. Create a pull request. Merge pull request. Confirm merge. Now the development is having latest changes, latest data. Development is having latest data. Development is the default one. So normally in real-time projects, we use the default branches, so master or main branch. Master or main. Okay. Now I just want to change back. But as per the requirement, you can update. Okay, fine. Next one, important settings, which are, for example, every repository is having owner. Right? So for example, the owner is living from the organization. Every repository is having owner. In real-time projects, every repository is having owner. That owner is living from the project or living from the organization. So how can we nominate new owner? Okay, and also how to convert public to private repository or private to public repository. So first one, how can we change the owner? Second one, how can we change public to private, private to public? Third one, so once the project is completed, how can we archive the data? How can we take the data? Fourth one, how can we delete the repository? These settings are very, very important. Okay. So how can we check these options? Go to settings here. Now scroll down. Completely scroll down here. Scroll down. Yeah, this is the danger zone. Danger zone. So normal developers, normal DevOps engineers, they will not have any access here, right? So only architects, solution architects, and managers, leads, they will have access. Now look at my screen, everyone. Change repository visibility. So currently we are using public. How can we change to private? Click on change visibility. Change to private. So if you want to change to private, yeah, you need to provide the credit card information. It will not allow you to convert directly without credit card information. Some charges will be applied. Okay. Next one, disable branch protection rules. If you want to disable any branch protection rules, you can click on this and you can disable. Next one, transfer ownership. So repository ownership, if you want to transfer, so click on transfer and you can give the new owner information. Choose an owner, new owner information you need to provide. Okay. Next, fourth one. Look at my screen. Archive this repository. How can we archive this? How can we take backup once the project is completed? How can we archive? Right? So by using this, we can archive. Next one, delete this repository. How can we delete the repository? These settings are very, very important. Clear, right? You know? These settings are very, very important. Right? So these are, we can say, danger zone. So we should not touch this. Okay, in real-time projects, will not be having any access. Okay, for these options. Only architects, solution architects, managers, leads. Fine.
The disable branch protection means what?
Branch
What
protection
issue?
rules.
What
Branch
issue?
protection rules means in private repositories normally. So branch protection rules we enable. Branch protection rules, branch change, switch, or branch merge rules we can enable whenever you want. That rules you can disable if you want disable.
Okay.
No.
For this archive and delete, do we have any timelines, Ram?
Timelines means once project is completed, manager asks you to archive the data. Manager asks developer to archive the data, not DevOps engineers. Okay. So by the time they archive the data. So deletion, normally managers, they delete the repository. Managers, once the project is completely delivered, then only they can delete the repository.
Okay, thank you.
Fine. Yeah. So today we discussed about 4 real-time scenarios: Git stashing and also GitHub settings, right? So tomorrow we'll discuss about Git conflicts, which is a very, very important concept. Conflicts. So next one, Git Rebase, Cherry Pick. These 3 concepts are very, very important. Interview questions also. Fine. So tomorrow we'll work on that 3 concepts. After that, Git tags, Git clone, Git fork, different concepts are there. So mostly by tomorrow day after Friday, by Friday we are going to complete the Git. So after that Friday, we'll start Jenkins introduction. Jenkins introduction also we can complete on Friday. Saturday, everyone available, right? Saturday, everyone available, right? Anyone having any issues? So 2-hour session, Saturday. Saturday, we can start Jenkins. We can work on Jenkins.
Any running notes will be sending for Git?
Yeah, I'll provide one document. So
Okay.
entire document, all the concepts are available once we complete the Git.
Ram, Saturday timing?
Saturday, 7 to 9. 7 to 9. Is it fine for you, everyone?
Evening, right?
Yeah, evening, 7 p.m. to 9 p.m.
Okay.
For me, it is like 8 to 10 is fine.
Okay. Yeah, we'll see that. Everyone available? So we can start at 7 p.m. or else we'll start at 7:30 p.m. also fine. We'll see that. Okay. Yeah, fine. We can stop here. Yeah.
Sir, one doubt.
Yeah, go ahead. Yes.
Yeah, in real time, like developers will push the code to like not master, right? Normal branch only, right? Because they need to merge, right, to the master.
Normally, developer push the code to development branch only. Development branch and sprint 1 branch, sprint 2 branch, they will push. So after that, pull request will be generated. If you want to buy that, I'll show you while working on Jenkins. While working on Jenkins, there is a concept which is multi-branching pipeline. In that, I'll explain. Okay.
Thank you.
Yeah. Fine. Fine. Right. Yeah. So we can stop here. Fine. Thank you all. Can you see my screen, everyone? Can you hear me?
Yes, Ram, we can.
Yeah. Fine. So in the last session, we discussed about Git stashing for real-time scenarios, right? And also GitHub settings, right? So anyone having any questions so far? Any questions, anyone? So far, any questions?
Yeah, hi Ram.
Hi, yeah.
So regarding that yesterday's topic, right, Git slashing. So you gave one scenario, you executed one scenario, right? First, you have created /1 is the file. Okay. After that, gave commit.
Yes, yes.
Again, you have edited that file.
Yes, yes.
After that, Git stash executed.
Yes, yes.
Yeah. After that, you created one more file.
Yes.
One more file, that is that one you created and committed. Okay. That is done. So I have followed the same steps. Whenever I am establishing connection with remote,
okay,
I am getting the same error. Refused, failed to push some updates were rejected because the remote contains work that you do not have locally.
So why we need to pull the latest code from remote to local? Why you try to pull the code?
Not pulling. I am saying up to
what are the
push
command
the
you
code.
executed? So okay, you try to push, right?
Yeah, I tried to push the code.
Yeah. As explained, so before going to push the code, first we need to get the latest code from remote to local. Otherwise, you'll get the errors. Okay. So every developer, first of all, they need to pull the latest code from remote to local. So on top of that, they need to start the development.
Okay. For slashing also.
Yeah.
Okay. Yeah, I did not do that one. So I have started this slashing one, whatever yesterday is.
Yesterday I explained that. Okay. So hope you can go through the recording. You will understand.
Sure. For slashing also, I need to do this.
Yeah.
If we are having any local committees there, means it won't accept, right? That is the one.
Yes. Correct.
Sure. I will go one more time.
Yeah. Any other questions, anyone? Fine. Yeah. Today we are going to discuss about 3 different concepts that may take another 10 minutes, 15 minutes extra today. Okay. So maybe 9:15 or 9:10 we can wind up the session. Okay. Right. So first concept here is important concept, which is very, very important. Every development team, every developer do the mistakes like, they do the mistakes so that they will get the conflicts. Okay. So how can we check that as a DevOps engineer? What are the conflicts they get? Let's try to understand. Okay. So Git conflicts is a concept. Conflicts is a concept. First of all, what is conflict? Anyone? What is conflict? Conflict and
Two persons are writing on the same file, and one has to getting accepted. So there will be a conflict whose changes will go to the production.
Right. So two changes, right? So for example, there is a requirement, application development. Okay. So 3 developers are working on the same requirement, same application development, but 3 people, they gave 3 different values. 3 people, they gave different values, but same requirement they're working with. Okay. So that what will happen? Git will be confused which value is the correct value. For example, look at my screen, everyone. 3 developers working on the same requirement. So here, developer A is working on master branch. Yeah, developer A, what he did here. So here, he created a file, conflicts.txt. In this file, he gave the value x equal to 5. Okay. Second developer started the development. Developer B started the development. Developer B started working on the application development, is working on development branch, not a master branch, is working on development branch. Okay. So once we create the new branch, what will happen? Anyone? Once we create the new branch, what will happen?
Same code will come to development
Latest
branch,
code
whatever
will
there in
be
the
taken
master.
to the new branch.
Yes, the same code will be replicated to the new branch. Okay. So same file available here, conflicts.txt, and x equal to 5 replicated. Second developer, what he did, he modified the code into x equal to 10. Okay. So again, third one also started the development. Developer C is working on hotfix branch. Okay. So once we create the new branch, same code will be replicated. This same code will be replicated to the new branch. Right. So developer C, what he did here, he modified the code x equal to 15. Okay. So same application development, but 3 developers gave 3 different values here. Okay. So developer A, he gave the x equal to 5. Developer B, x equal to 10. Developer C, x equal to 15. 3 developers gave 3 different values. Now, once modify this code, developer C, what is doing here? Is trying to merge this code. Is trying to merge the code to master. Once he merge the code to master, what will happen? This value will be updated. This value will be updated to x equal to 15. So value will be updated, right? X equal to 15 will be updated. Right? Yeah. Now, second developer also is trying to merge the code to master. Second developer B also trying to merge the code to master. So in this case, what will happen? So here, this guy also trying to merge the code to master. So here, when you try to merge the code to master, you will get conflicts. So why the developer B while merging the code to master is getting conflicts error? Okay, because here what happened? So whatever the latest data is available on master, which is x equal to 15, which is not available on the development branch, the second branch, right? So here this developer B is trying to merge into master. So in this case, you will get the conflicts. Definitely will get the conflicts. Okay. So once you get the conflicts, what we need to do? They will directly call you, mail you. We are unable to merge the branch to master. We are getting conflicts. Could you please check and fix the issues? They will ask you to fix the issues. They will not ask you to fix. They ask you to check. Could you please check the issues? They will ask you to check. In that case, what we can do? Yeah, there is a tool here, which is Git merge tool. There is a tool which is Git merge tool. By using that Git merge tool, we can check the issues. There is a tool which is Git merge tool. So by using this, we can check the issues. We can identify the issues. Okay. So once we identify the issues, we can inform to the development team. Okay. We don't need to fix. We don't need to worry about the coding part. We don't need to involve into the coding part. Clear, right, everyone? Yeah. So practically we can work on this so that you will understand. Okay. So same scenario, practically we can implement so that you will understand. Okay. Yeah. So to avoid these conflicts, what we have to do, what they need to do, developers, they need to use one more concept, rebase. That I'll explain once we complete this. Okay. So while working on rebase, I'll show you that how to avoid these errors. Okay. Fine. Now let's go back to the conflicts. Open the Git bash here. Right. Now, so here Git init. Now it is initialized. Now I'm in master branch. Okay. Developer A, he started working on the master branch. Vi configs.txt insert hi. This is conflicts test x equal to 5. He gave the value x equal to 5. Escape, save and quit. Right. After that, git add space dot git commit -m commit message. Master changes something. Yeah, now the code is committed. So once we commit the code, after that, second developer started working on the activity. Git branch name, development. So once we create the new branch, the data will be replicated to the new branch, right? So here, git checkout development ls, same data is available, right? Now if you check vi configs.txt, so look at my screen, everyone. So x equal to 5, same data available, right? So second developer, what he's doing here is modifying the code. Insert x equal to 10, modify the code. Escape, save and quit, right? Now git add space dot git commit -m commit message, dev changes. Now git checkout master. Now one more branch. Third developer also started development, started working on the application development. So here Git branch name hotfix. Git checkout hotfix. Now same data available right here. vi hotfix.txt. Sorry, config.txt. So here third developer is modifying the code. X equal to 15. Okay. Escape, save, and quit. Now git add space dot git commit -m commit message hotfix changes. Code committed, right? So three developers gave the three different values. Right? So now third developer C, is trying to merge the code to master. Yeah, so git checkout master. So as per the scenario, in the master branch, the value here is cat config.txt. X equal to 5. In hotfix branch, what is the value? X equal to 15, right?
15.
Yeah, in the hotfix branch, we gave X equal to 15. Now, developer C is trying to merge into master, right? So git merge hotfix. So hotfix is merged. Hotfix is merged to master. Now, if you check here, cat config.txt, look at my screen, everyone. The data is updated, right? So earlier it was X equal to 5. Now it is X equal to 15, right? Yeah. So now second developer also trying to merge the code to master. So developer B also trying to merge the code to master. In that case, what will happen? Practically, we can check. Okay. Now git merge development. You will get the conflicts. Look at here. Automatic merge failed. Fix conflicts and then commit the result. Understanding right, everyone? So first merge will be allowed. Second merge will not be allowed. Because so first merge, once merge happened, latest code available in the master. That is not available in the development branch. That is why we are getting automatic merge failed, fix conflicts and then commit the result. Okay. So currently no changes here. You check here cat config.txt. So it is confusing now. Git is confusing now. Which value is the correct value? Confusing now. So in that case, what we have to, developers, what they will do, they call you, they mail you. Okay. So unable to merge the code to master. Could you please check it out? Okay. So wait for 2 minutes. We can tell them, wait for 2 minutes and we can execute the command like, which command? Git merge tool. So this git merge tool, when we install Git, along with the Git merge tool also install. Okay. Enter. Now it is checking. Look at here. Enter. 3 times you need to enter. Okay. 1 time only. 3 times no need to enter. Only 1 time. Look at here, everyone. So one developer gave the value X equal to 15. Other developer gave the value X equal to 5. So another developer gave the value X equal to 10. So 3 developers gave the 3 different values. Which value is the correct value? Git is confusing. Which value is the correct value? Git is confusing. That is why we are getting conflicts. Okay, so we need to take this screenshot and we need to share with the development team. They will check it out. They will merge the correct value. So senior developers, what they will do, they ask you to merge. Okay, anyways, you open Git merge tool. So 10 X equal to 10 is the correct value. So please merge. They will ask you to merge. So in that case, what we can do? Can we merge or not? As a DevOps engineer, we should not involve into the developing part only. If you merge that, what will happen? Definitely that will track on your name, the commit IDs will be generated. So that if anything goes wrong, any issues happen, so definitely will be pointed. That is why we need to be very careful. We need to be very careful. So we should not involve into the development part. So we need to take the screenshot and send it to the respective team. So you can loop your manager and lead so that they will take care of this. Okay. So we should not involve into the developing part. If you involve into developing part, so definitely that will be tracked on your name, commit IDs will be generated so that if anything goes wrong, you will be pointed. That was happened in our project. Okay. So we need to be very careful. Should not involve into the. So if it is startup company, small company, so if they assign the roles, development role, that is different. Okay. So normally as a DevOps engineer, we no need to involve into the developing part. Okay. Clear, right, everyone? Any questions, anyone? You understand the concept, right, everyone? Conflicts. Okay. Yeah. So one more concept, one more important concept, which is Git Rebase. Git Rebase.
Ram, before going here.
Yes.
Yeah, we are unable to update, right? Second developer's value, we are unable to merge.
So as a DevOps engineer, we'll be having access. Okay.
Okay.
So we can also access, but that is not a process actually. Should not involve into that.
But when we executed the command, right now, just now it's shown, right? Not able to
That
merge.
command is for checking only. Okay.
Okay.
Checking only. Right.
Okay. Just we will verify and we will send the screenshot. That's
Yes. Yes. Correct.
okay. They will do the code and they will merge.
Yeah, they will take care. Yes.
Okay.
Right.
Thanks. Yeah. Thanks.
Right. So next concept, important concept, rebase, Git rebase. Okay. So what is rebase? Why we require rebase? Let's try to understand first. Okay. So rebase is nothing but, I'll explain that. We are going through scenario basis, right? Now, for example, there is a master branch. Here in the master branch, so in the master branch, we have 3 commit IDs. M1, M2, and M3. 3 commit IDs available. Okay. So now I create one more branch, which is a development branch. So once we create the new branch, what will happen? Latest code will be replicated from master to development, right? Now, yeah, in the development branch, developer, second guy, he added 2 more commits. D1, D2. Okay. Now I create one more branch for other guy, which is hotfix. So once we get the hotfix branch, same data will be replicate, right? From master to hotfix. So your third guy, third developer is adding 2 more commits here, H1 and H2, right? Yeah, 2 more commits added here. Right. Now, developer, okay, this is a developer A, developer A. Developer B, and developer C. Okay. So developer C, what is doing here is merging the branch to master. So once he merges the branch to master, hotfix branch merge to master. What will happen here? H1, H2 will be merged to the master. H1, H2 will be merged to the master, right? H1, H2 will be merged. Fine. H1, H2 merged. Now, second developer B also trying to merge into master. Developer B also trying to merge into master. So in this case, what will happen? When I try to merge to master, you will get the, what will happen?
Conflict.
Conflicts, right? Conflicts. Conflicts. So that is why to avoid this conflicts, what we have to do? We need to use the rebase. This is the rebase. So instead of merging development branch to master branch, first thing what we have to do, very first thing what we have to do. So already one branch merged here. Hotfix branch is already merged. Development branch is not merged. In this case, what we can do? So before going to merge development branch to master, we need to rebase. We need to rebase master to development. First, we need to rebase master development. So that what will happen? Latest code will be rebased to development branch. Latest code will be rebased to development branch from master. Latest code. So yeah, once we rebase, later we can merge. It will allow. It will allow. Understanding, right? Later we can merge. Understanding, right? So yeah, when you try to merge second branch to master, we'll get the conflicts. That is why what we will do, what we need to do, we need to rebase master to development so that this H1, H2 will be rebased to the development branch. Later point of time, you can merge. It will allow. Clear, right? So once we rebase, we are talking about rebase. Once we rebase, the committed sequence would be, what the committed sequence would be? Any guess, Nipa? Once we rebase master to development, what is the committed sequence? Anyone?
M1, M2, M3, H1, S2, D1, D2.
M1, M2, M3.
And H1, S2.
Okay. H1, H2.
And then D1, D2.
D1, D2. So everyone is okay for this sequence? Others? It is fine, everyone?
Actually, we are rebasing this development one, right? So on the development, we are merging it. Okay. Yeah.
Right.
I'm okay with it.
Yeah. So once we rebase master to development, the committed sequence would be the same sequence. Yes, correct. This is the sequence. Okay. M1, M2, M3, H1, H2, D1, D2. This is the sequence. Okay. Yeah. Now practically we can execute this. Practically we can work on this so that you will understand better. Any questions so far? So far, any questions? Any other questions, anyone? Any other questions, anyone? Yeah, interviewer asks you. Yeah, so we have multiple branches available. So second branch merged to the develop master branch. So that is successfully merged. So other branch, when I try to merge, it is giving some issues, conflicts. What we can do? First, we need to rebase. master to target branch. Later we can merge. Okay, simple answer. Fine. Now let's move on. Let's go and execute this. Rebase. Git bash here. Right. So git init. Now it is initialized. Vi on master branch. Now what we can do? m1.txt, insert m1, escape, save and quit. Now git add space dot git commit -m commit message m1. Now m2.txt, insert m2, escape, save and quit. Now git add space dot git commit m2. m3.txt, insert m3, escape, save and quit. Now git add space dot git commit m3. Now if you check here git log, look at my screen everyone, m1, m2, m3 available on master branch, right? Now I want to create one more branch, git branch, branch name, development. Now git checkout, development. Now I'm in development branch. Now if you check ls, same commits available. Now vi d1.txt, insert d1, escape, save and quit. Now git add space dot git commit -m d1, d2.txt, d2, save and quit, git add, git commit, d2. Right. Now if you check git log, here we have 5 commits, m1, m2, m3, d1, d2. Right. Now I want to create one more branch for which git checkout master. Now git branch hotfix, git checkout hotfix. Now if you check ls, only 3 commits are available on the hotfix. Only 3 commits. Okay. Now what I will do, I want to create 2 more commits here, right? Vi h1.txt, insert h1, escape, save and quit. Now git add space dot git commit -m h1, h2.txt, insert h2, escape, save and quit. Now git add git commit h2. Okay. Now if you check here git log, m1, m2, m3, h1, h2 available on hotfix. Now what I will do, I want to merge hotfix to master, for which git checkout master. Now git, okay, in the master branch, how many commits are available? Anyone? In the master branch, how many commits are available?
3.
Oh, sorry.
3 commits. The master branch, we have m1, m2, m3 only, right? Not at merge, right? Not at merge. Clear, right, everyone? Yeah. Now what I will do, I want to merge hotfix to master. Git merge hotfix. Now hotfix merged. Look at here, everyone. H1, H2 merged to the master. Okay. Now if you check here, git log. Look at my screen, everyone. M1, M2, M3, H1, H2 available on master. Now, if you merge second branch to the master, definitely we'll get the conflicts. That is why what we will do, instead of merging development branch to master, we need to rebase master to development, reverse concept. We need to rebase master to development, reverse concept, right? Yeah. Now, when you want to rebase to target, we need to switch to the target branch first. Git checkout development. So in the development branch, if you check your Git log, look at my screen, everyone. M1, M2, M3, H1, M1, M2, M3, D1, D2 available. H1, H2 not available here. That is why what we have to do, we need to rebase master to development, reverse concept, right? For which command here is Git Rebase master. Git Rebase master. So once you execute this command, what will happen? The commit ID sequence would be like this: M1, M2, M3, H1, H2, D1, D2 on the development branch. This is the commit ID sequence in the sequence will be on development branch. Clear, right, everyone? Yeah. Now I want to rebase. Git Rebase master. Enter. Successfully rebased. Updated references heads development. Development is having latest code, right? Now, if you check your Git log, look at my screen. M1, M2, M3, H1, H2, D1, and also D2. Look at here. D1, D2, H2, H1, H2, H1, M2, M3, M2, M1, M3, M2, M1. So bottom to top, actually, we need to read this: M1, M2, M3, H1, H2, D1, and D2. Clear, right, everyone? This is the committed sequence. Understanding it, everyone? Any questions so far, anyone?
Yes, Ram. So in this, whenever we are doing a rebase, we have to take a permission, right? Before that, we have to check for the conflict. If it is there. Conflict is the mandatory thing we have to encounter first.
That will be happened in the real time. Yes. But the
And
concept
then
you need to understand first. Concept wise, you need to understand, right?
Yeah. If management permits, then we can rebase. Rebase is not the to remove the conflict, right?
Yes. We need to get approvals. Yes, you're true. You're correct. Yes. Without approvals, you should not rebase, should not merge into master. Okay. Yeah. Now, any other questions, Andy? Anyone? Any other questions, anyone? One more concept is there. Important concept, interview question. Most of the interviews asking this question. So before going to that, any questions, anyone? Is it clear to you, everyone? Rebase concept is clear, right?
Conflicts and rebase, do you have any link, these two?
Yes. Yeah, to avoid conflicts, we need to use the rebase, right?
Yeah. Earlier you shown the dashboard, means the UI.
So to avoid the conflicts, so for example, in real time, in our previous project, actually, Capgemini project, I worked with Capgemini. So 18 branches we used to use in our project, 18 branches, 180 branches. So multiple developers working on those branches. In that case, what they need to do? Every time they use the rebase command. Otherwise, what will happen? Conflicts.
Yeah.
Right? Yeah.
Sure, thanks.
Right. So last concept, which is a very, very important concept, interview question also, which is cherry pick. Cherry pick. Very important concept. Most of the interviews asking this question. Okay. Yeah. So scenario basis. What is cherry pick? Why we require cherry pick? Let's try to understand first. Okay. Yeah. So here, same way we have master branch. Yeah, in the master branch, we have two commit IDs, M1, M2. So we don't need to create more commit. only 2 commits. Okay. Yeah. Now I create one more branch, which is a development branch. Yeah. So once we get the branch, new branch, what will happen? Latest data will be replicate from master to development. Right? Yeah. So here, developer added 3 more commits here. D1, D2, and D3. Right? So now if you merge development to master, what will happen? And if you merge development to master, development branch to master, what will happen? So when you merge development to master, what will happen?
Is all checkouts will go to master.
Right. So all these commits will be merged to the master, right? D1, D2, D3 will be merged to the master. But my client requirement here is, okay, D1 is having some issues. Not D1, D3 is having some issues. D1 is not having latest code. My client asked me to merge only D2 commit ID. D2 is having latest code, no errors, no issues. Okay. My client asked me to merge only D2 committed. D1 is not having latest code. D3 is having D3 is having errors. We don't require. D1 also not required. So my client asked me to merge only D2 commit ID to the master. In that case, what we can do? So here, by using cherry pick, we can achieve this. Okay. So if you want to merge only particular commit ID, we use the cherry pick. Only particular commit ID, one commit ID at a time. We can use the cherry pick. Clear, right? So if you want to merge entire branch, we can use the merge command, right? But if you want to merge only one commit ID, so we need to use the cherry pick. Clear, right, everyone? Yeah. Now let's go and execute this. So another 5 to 10 minutes, Andy. Another 10 minutes hardly. Okay. Yeah. Now, cherry pick. Git bash here. Git init here. Now, vi, our master branch, vi, m1.txt, insert m1, escape, save and quit. Now, git add space dot, git commit -m commit versus. Now, m2.txt, set m2, escape, save and quit. Now, git add, git commit m2. Now, if you check here, git log only, we have two commits available, m1, m2, right? 2 commits available. Now, yeah, one more branch we can create here. Git branch name. Yeah. So now the development branch is created. Now, if you check here, git checkout development. So now if you check here, git log, we have same commits available, right? Once we create the new branch, what will happen? Latest code will be replicated from master to new branch. Now the same code is available on development branch. Now what we can do here? Yeah, so developers, they create 3 more commits here. vi d1.txt, insert d1, escape, save and quit. Now git add space dot, git commit -m d1, d2.txt, insert D2, escape, save and quit. Yes. Now D3.txt. Insert D3, escape, save and quit. Now git add, git commit D3. Right? Now if you check here, git log, we have M1, M2, D1, D2, D3. 5 commits available, right? On development branch. So on development branch, we have 5 commits available, right? So D1 is not having latest code. Just imagine that D1 is not having latest code. D3 is having issues, errors. Only D2 committed should be merged to the master, right? So normal in real-time projects, so as per the requirement, we need to merge the particular commit IDs. So this commit ID is not required. Client asked me to merge only D2, not entire code, not entire commit IDs. So in that case, what we can do, by using cherry pick, we can achieve this. We can merge the respective commit ID to the master. Clear at everyone? Right. So now git checkout master first. Yeah. So in master branch, we have 2 commits only available, right? M1, M2. Look at my screen, everyone. So in master branch, only 2 commits available, M1, M2. Now I want to merge only one commit ID, which is the D2 commit ID, for which the command here is git cherry pick, space. So you can take the commit ID here, D2 commit ID, just highlight this, just copy this, highlight this, paste here, right click here, enter. What happened here? Only D2 commit ID merged to the master. Now if you check here, git log, M1, M2, D2 commit ID available on the master branch. Clear at everyone? Is it clear to you? So this is a very important interview question. Interviewer asks you, interviewer, they will not ask direct question. What is cherry pick? Why we require cherry pick? They will not ask. They will give you scenario. I have master branch. On master branch, we have 3 commit IDs or 10 commit IDs. Okay, so we have development branch also. In the development branch, we have 5 commit IDs. D1, D2, D3, D4, D5. D1, D2 not having latest code. D4, D5 is having errors. So D3 commit ID only I want to merge into master. How can we merge? Like that, they give you scenario. So answer is simple. Question is big one. So by using cherry pick, we can merge. Clear, right, everyone? This is mandatory question. Cherry pick is the mandatory question. Fine. Yeah, make sure everyone practice these concepts. 3 concepts: Git configs, Git rebase, cherry pick. So tomorrow we'll discuss about Git tags, Git clone, fork. Okay, after that, that will take hardly 30 minutes. So after that, we can start Jenkins introduction. So tomorrow we'll start Jenkins introduction. And Saturday, everyone is okay for that Saturday session, right? Saturday session, 2-hour session. Because we are slowly moving, right? So I want to cover 2-hour session Saturday.
Ram, if it is possible, I mean, have a same time means 8. We are having a regular class now. From there, any extension, whatever suits.
8 to 10 is okay, everyone? So 10 is a bit late, right? That is why
8 to 9:30 also okay. I mean, if work out with everyone.
Okay. Okay, we'll discuss tomorrow. Okay, fine. 30 minutes plus or minus we can plan. Okay, yeah. Fine. So we can stop here. So make sure everyone practice, and Git also very, very important tool. Okay, everyone practice. So tomorrow I'll show you a real, not tomorrow. maybe while working on, okay, not tomorrow, Saturday I'll show you real code. Saturday I'll show you real code. So far we are getting only text files. So text files, when you try to pull, when you try to build that, okay, Jenkins will not accept. Okay, so jobs will be failed. Jobs will be failed. That is why we need to use the real code. That real code you need to fork. Fork means, yeah, from my GitHub account, you can take my code. From my GitHub account, you can take the code. That is forking. I'll show you that. How to fork. Okay, on Saturday, so we'll work on that. Fine. So make sure everyone practice and brush up cheskondi. You can brush up yourself so that these concepts are very, very important concepts. Okay, fine. Yeah, thank you all.
Ram?
Yeah, go ahead. Yes.
One general question, Ram. Just
Yeah.
whatever I observed, right? These files you are multiple files you are creating. Okay. After that, when you are moving staging area and commit, right? Individually you are doing that method git add dot and commit method. Do we have any this bulk commits method? Doing multiple files same
Yes,
time?
yes. At a time also you can commit. Yes. I'm one by one I'm committing, right? So
Yeah.
even at a time also you can commit. But if I commit like that, you will be confused. That is why.
Sure.
Yeah, one by one I committed. Okay.
Sure. Thanks.
Fine. Yeah. Fine. So we can stop here. Yeah. So tomorrow we are going to complete this. We'll complete this Git services and we'll start Jenkins introduction tomorrow. Fine. Yeah. Thank you all. Can you hear me, everyone? Can you see my screen?
Yes, Ram.
Yeah. Fine. So in the last session, what we discussed, anyone? We covered three services, right? We discussed about three services, which are Git configs, Git Rebase, Cherry Pick, right?
Yeah,
So
yes,
the concepts, right? We discussed. Anyone having any confusions, any questions? So far, any questions, anyone?
Ram, it's regarding.
Yeah, go ahead.
Yeah, it's regarding Stash, Ram.
Git Stash. Okay, Stash.
Yeah. So the day when we have done file 1. Okay, file 1, line 1 is committed. Again, line 2 we have appended.
Yes.
Okay, next file again means we executed this stack command.
Okay.
After that, file 2 created.
Yes.
Okay. So what I have done is I before these two things I pulled the code from remote. After that, I have executed commit from local to remote. That time what happened, right? File 2 two lines moved, file 1 committed data moved.
Okay.
So whatever the uncommitted one, right, in file 1, that did not move. So that is the one.
Yes. Correct. So every time, make sure we need to move the code into staging area and we need to move the code to, we need to commit the code, right? So that is the process every developer should follow. Every time we need to add into staging and commit the code. That is mandatory. Okay.
Yeah, sure. Thank you.
Any other questions, anyone? Yeah. So today we are going to discuss about 3 more concepts. Okay. So first one is very, very important concept, which is interview question also. Most of the interviewers asking this question. Difference between SVN and Git. Difference between SVN and Git. What is SVN? Anyone having idea? SVN. Anyone heard about this?
Subversion node.
Yes, subversion, right?
Yeah.
Subversion. So before Git, we used to use SVN. So every project team, they used to use SVN before Git, right? So SVN is completely failed. SVN is failed because of SVN is having some drawbacks. I explain that. Okay. So successfully Git is every project team they're using successfully, right? Every project team yeah, they're using successfully running Git, right? So because of Git is having thumb rules, very important thumb rules. Okay. So let's try to understand what are the differences here. Okay. So we have 3-4 differences, major differences. Those are all very, very important. Okay. So interviewer asks you this question, mandatory question. So we need to explain properly. Okay. Yeah. First difference here is SVN is centralized version control system. SVN is centralized version control system. Git is distributed version control system. So centralized version control system, distributed version control system. What is the difference here? Let's try to understand. Okay. Now let's try to understand SVN workflow. SVN workflow or SVN architecture. In SVN architecture, same as Git, what we will do? We create workspace. So in the workspace, developer start the development. Once the development is completed, the code should be moved to staging area, or we can say index area. So after that, from here, the code should be moved to central repo. This is central repository. Right? So this is SVN architecture. So in SVN, so developer, once they develop the code, once they started working on the local workspace, the code should be moved to staging area. So after that, once they commit the code, directly the code will be moved to the central repository. Clear, right, everyone? Now let's try to understand Git architecture. In Git architecture, what we will do? Yeah, same as SVN, we create workspace. This is a workspace. In local workspace, developer start the development. Once development is completed, they push the code to, they move the code to staging area. Staging area. After that, the code should be commit to commit area, which is Git local. This is a commit area, or we can say Git local. Right? So after that, the code should be moved to GitHub, which is a remote repository. Yeah. So what is the major difference here? Anyone? What is the major difference here?
It's directly committing to the centralized repository.
Right. Okay.
Commit not.
So we can say this is commit area. This is commit area. This is a commit area. Okay. Once we commit the code will be moved to the central repo. The difference, major difference here is SVN is having only one repository, which is central repository. SVN is having only one repository, which is a central repo, right? But Git is having two repositories. What are those? Local repository and also remote repository. So Git is having two repositories, local repository, remote repository. SVN is having only one repository, which is the central repo. Fine, that is okay. Sometimes what will happen in real-time projects, sometimes what will happen, this remote servers will not be accessible. So this remote servers, whatever the servers are available here, okay? So here, this remote server, sometimes due to some maintenance activity, these servers will not be accessible. In case the servers are not accessible, remote servers are not accessible, so in SVN, development should be stopped because where we can commit. So if you commit the code, the code will be moved to directly central repo, right? But whereas Git, in case the remote server is not reachable, not accessible, GitHub is not accessible, the developer, they commit the code in their local Git. Once the remote server is available, reachable, they can move the code to GitHub. But whereas SVN, so only one repository, they cannot commit the code. Development should be stopped. But whereas Git, development will not be stopped. These are the advantages here. This is the main difference here. SVN is centralized version control system. Git is distributed version control system. So this is a main difference, important difference. Okay. Clear, right, everyone? SVN is having only one repo, which is central repo. Git is having two repositories, local repository and also a remote repository. In case remote server is not reachable, so in Git, developers, they commit the code in their local Git. Once the remote server is available, reachable, they push the code to remote repository. This is a very important difference. First difference. Okay. Yeah. Next one, second difference here is second difference, important one. SVN will allow all the file formats. SVN will allow all the file formats like binary files, image files, video files, spreadsheets, whatever, all the file formats. And file size limit is, SVN will allow all file formats without any size limit. Without any size limit, like 1 GB, 10 GB, 10 GB, 100 GB, whatever the GB you want to upload, you can directly upload to the SVN server. Whatever the GB you want to upload, you can upload to the SVN server. That is why SVN failed. Okay. But whereas Git is having some thumb rules. Git will not accept
100 MB.
Git will not accept binary files. And the file size limit is 100 MB only. Right? This is very important thumb rule. Git is having very important thumb rule. Git will not accept binary files. What is binary file, anyone? What are the binary files available? Anyone? Binary files.
Dot class files.
Images also we can call binary.
Yeah. So binary means zip files, right? Binary conversion files. Yeah, that will not be allowed by Git. Okay. So yeah, I give you a small example. In our previous project, in Capgemini project, so we used to use SVN server in 2013, 2014, 2015. By the time we used to use SVN server. So in SVN server, SVN, people used to upload their personal data also into the SVN server. So DevOps engineers, developers, testers, everyone, they used to upload their personal data also into SVN server, because SVN will allow all file formats without any size limit. 1 GB, 2 GB, 10 GB, 100 GB, 1000 GB also can upload to the SVN server. SVN will accept. So every alternate days, we used to see the SVN server performance issues. We used to get so many tickets. SVN is not accessible. SVN is having some performance issues. SVN is not allowing to log in. This type of issues. Because people used to upload their personal data also into SVN server. For example, in your laptop, you keep on storing the data. What will happen? So every day 10 GB, 20 GB you are storing into your laptop. What will happen? Definitely,
Slowness.
that will be impact to your performance, laptop performance, right? Same way, SVN server also. So yeah, people used to upload the data into SVN server. So that is why we used to get so many issues. We used to get so many tickets every day, every alternate days, right? So that is why in 2015, we decommissioned SVN server and we integrated Git. So far, we haven't seen any single issue. Not so far. So far, people are available in the same project. My ex-colleagues available in the same project. So still they are using the same server. Okay. Yeah. So this is a very important difference. Second difference. Okay. Clear, right, everyone? Yeah. So third difference here is SVN developed by Collabnet. SVN developed by Collabnet is the vendor. Okay. Yeah. So Git yeah. So Git developed by Linus Torvalds. Git developed by Linus Torvalds, the person who developed Linux kernel. Same person developed this Git kernel also. So that is why we can execute Git commands in, we can execute Linux commands in Git. Okay. So same Linux commands we can execute in Git also, right? Yeah. So next one, fourth reference here is SVN is having, SVN is completely GUI. SVN is completely GUI, graphical user interface. Git is having GUI, but we don't use GUI. We always use CLI, command line interface, right? So because, yeah, compare with Windows and Linux, which one is the secure one? Anyone? Compare with Windows and Linux, which operating system is the secure one?
Linux.
Linux, right? So most of the companies, most of the data centers, 98% servers, they're using Linux. Only 2 to 3% only, we are using Windows servers. Most of the production critical servers, we are using Linux only. Because, yeah, in Linux, we use CLI. In Linux, we have GUI also, but we don't use the GUI in Linux. We always use the CLI because compared with GUI, CLI is more secure, right? So whatever the applications we host on the servers, whatever the databases we host on the servers, so we need to protect them, right? So client business, client applications, client business databases, right? So that is why every company, every organization, every project team, they're using the Linux servers, right? Yeah, so these are the major important differences, 4 differences, right? So S1 is a centralized version control system, Git is a distributed version control system, and S1 will allow all file formats without any size limit, like 100 MB, 1 GB, 2 GB, 10 GB, 100 GB, 1000 GB also can upload into S1 server, right? S1 will accept. So Git will not accept binary files, and file size limit is 100 MB only, right? S1 developed by Collabnet is a popular vendor. Git developed by Linux Store Worlds, right? Who developed the Linux kernel. S1 is completely GUI. So Git is having GUI, but we don't use the GUI. We always use the CLI. So these are the important differences. So important interview question also. Okay. So most of the interviewers are asking this question. Clear, right, everyone? Any questions, anyone so far? Right. Next concept, important concept. Git tags. Yeah. So what is tag? What is the importance of tag? Let's try to understand. So tag is a archive file. Tag is a archive file, right? So tag is a archive file. Tag is archive file. So you can say tag is archive file. And to reduce the GitHub pricing, we use tags in real-time projects. Yeah. So understanding that, everyone? Tag is a archive file. So archive means binary. So you can convert into artifact, like archive. Artifact, not artifact, exactly. Archive file. So normal data we can convert into artifact, right? So tag is a archive file, and to reduce the GitHub pricing, tag is the archive file. So to reduce the GitHub pricing, we use tags in real-time projects. So for example, let us take small example here. For example, we have 3 branches. So this is a master branch. This is a sprint 1. This is sprint 2. Right? So here sprint 2 completed. Sprint 2 development completed. Okay. So sprint 2 data size is 100 MB, for example. 100 MB, for example. Right? So the project is completed. The application is delivered, deployed. Application is delivered and deployed. Okay. Still, if you are keep using the same space, what will happen? So GitHub is having some. GitHub is not free, right? In real-time projects, we use the private repositories, not public repository. For practice, we are using public repository, but in real time, we always use the private repositories. For practice, always use the public. Public one is not secure, right? But free. Private repository is fully secured, but not free. We need to provide credit card information, right? So here, sprint 2 is completed. Sprint 2 data size is 100 MB. So once the project is completed, once sprint 2 is completed, so if you hold that sprint 2, if you hold that sprint 2 branch, if you hold the sprint 2 branch, some charges will be applied. So that is why what we have to do, the sprint 2 we need to convert into tag. This we need to convert into tag. So once we convert into tag, this 100 MB size data will be converted into 9 MB something. 9 MB something. So size will be reduced, right? Once you zip the file, for example, you have 1 GB data in your laptop. So you zip that folder. What will happen? Size will be reduced, right? Size will be reduced, right? Same way here also, once the project is delivered, once the sprint is completed, the sprint branch, respective sprint branch, we need to convert into tag. So that what will happen? Once we convert into tag, what will happen? The size will be reduced. Once we convert into tag, the respective branch we can go and delete. This respective branch we can go and delete. So this tag, what we can do? This tag we can push to the GitHub for future reference. This tag we can push to the GitHub for future reference. Understanding, right, everyone? Is it clear to you, everyone? So tag is a archive file. To reduce the GitHub pricing, we use the tags in real-time projects. Once the branch, once the sprint 2 branch or sprint 1 branch delivered, so completed, development completed, we can convert into tag. The tag we can push to the GitHub for future reference. So size reduced, right, already? We can push to the GitHub and we can go and delete the respective branch to reduce the GitHub price. Clear, and everyone? Is it clear to you? Right.
Ram?
Yeah, go ahead. Yes.
Yeah, this archive means binary file.
Yeah. Convert it to zip. Yes.
Okay. But in previous slide, you told binary files it won't accept. Git.
Right. Very good question. Yes. So in GitHub, normally, for example, look at my screen, everyone. So yeah, your question is very, very valid question. Look at my screen here, everyone. So normally from Git to GitHub. So development team, when they develop any data, right, that should not be binary. Okay. So yeah, when you convert into tag, that is tags are okay. Tags will be allowed. Tags will be allowed. You understand, right, everyone? So tag is exceptional actually. It will bypass. Okay. So otherwise, if you try to push tar file, jar file, war file, will not accept. Okay. Don't confuse. I'll show you that practically. Okay. So tags, only tags will be allowed. Tag is binary. Yes. Yeah. Interviewer ask you this question. Yes. Very important one. Okay. So you are saying something like Git will not accept binary files. But tags, how can we push? But tags will be allowed by Git. Okay. Yeah. That we need to clarify while attending the interviews. Fine. Yeah. Now, what we can do? So now go back and work on this Git tags. Okay. So one more concept is there. After that, Git clone, important one. Okay. So now go back to local workspace. Tags. Open Git Bash here. Git init here. Now, so I want to pull the code from GitHub to local, and that code I want to convert into tags. Okay, fine. So for which, go back to GitHub account. So this is our repository, right? 114. Copy the GitHub repository URL. So currently look at my screen, everyone. So currently no tags right here. 0 tags. No tags are available. No tags are available, right? 0 tags. Now what I will do, git remote add origin space remote repository URL. Yeah. Now git pull origin to master. So normally the respective branch, sprint 2 or sprint 3 or sprint 4, whatever branches are there, those we can pull into local. But here I'm pulling master. Okay. So as per the requirement, we need to pull the respective branch. Now look at my screen, everyone. These are the files available. Now this data I want to convert into tag. How can we convert? So command here is git tag space tag name sprint1. For example, sprint1, right? Enter. So now the tag is converted. Now this data I converted to archive tag, right? Now if you want to check the tags, command here is git tag is the command to check the tags. Look at here. We have only one tag, which is sprint1. This tag we can push to remote repository, right? For future reference. For future reference, we can push this tag to remote repository. How can we push? Git push origin sprint1. We don't require -u. Okay. Git push origin sprint1. Enter. Now the data is pushed. Sprint1 is pushed. Tag is pushed, right? Now go back and check. Currently it is 0, right? Now refresh here. What happened here? Tag is pushed. Look at my screen, everyone. This is a zip. Okay. Converted. Now go back here. So once we push this tag to remote repository, go and delete the respective branch. We don't require respective branch. Okay. So for example, sprint1 is not there. Okay. Anyways, I want to delete the hotfix. Respective branch. How can you delete? So go to branches. Click on branches. Now look at my screen, everyone. There is a delete symbol right here. Delete symbol. Delete branch. Go and delete the branch like this. Click on delete. Now the branch is deleted now. Understanding that, everyone? Clear, right, everyone? Concept is clear, right? Yeah. Now I want to create one more branch, one more tag here. vi tag.txt. Okay. Tag.txt. Insert hi. This is tag testing. Escape, save and quit. Now git add space dot git commit -m commit message tags. Now this file I want to convert into tag. How can we convert? Git tag space tag name sprint2. Now the tag is converted. Now if you want to check the tags, git tag is the command. Look at my screen. Sprint1, sprint2, right? 2 sprints are available. Now sprint2, I want to push to the GitHub. How can we push? Git push origin sprint2. Now the code is pushed. Go and check here. So currently, yeah, here earlier one tag only, right? Now look at my screen. 2 tags are available. Sprint1 and also sprint2. 2 tags are available. Got it right, everyone? So like this, n number of tags we can push to the remote repository. Understanding that, everyone? Yeah, tags are very important. Okay. Next one. one more concept, important concept. Git clone.
Ram, from tag, can we create a branch once again?
Can you come again?
Can we create a branch once again using a tag?
No. If you want to create a branch, go and create here. Here you can create. Here. Give the
No,
name.
my question is, we have created a tag in order to zip the file and compress the files, right? And we release the branch.
Yes.
Now the data is in the tag itself.
Yes.
Now I wanted to get the same data maybe later in the GitHub once again to start the development process. Now in that case, the data has to be extracted out from the tag.
No, not like that. So here, go to tags, simply go to tags, click on this zip file, look at here. The download, right?
Download.
This data
Then,
we can add into the respective branch.
Okay. Got it.
Yeah. Fine. Now, next concept here is Git clone. What is clone, anyone? What is clone? What is the importance of?
Same functionality which is earlier.
So normal in general, what is clone? Anyone? Duplication. Yes, exactly. Duplication, right? In our iPhone or Android mobile, so we have WhatsApp, right? We can clone the same app if you have second SIM, right? And we can configure second WhatsApp, right? So duplication. Clone is a duplication, right? So why we require clone? Right? So in Git, so for example, here look at my screen. Git pull origin master. What is this command? Where we use this command? Anyone?
To retrieve data from a master branch from remote.
Yeah, to pull the code from GitHub to local. To pull the code from GitHub to local, we can use this command, right? Yeah. So here, instead of using git pull origin master, we can use one more command also, which is git clone repository URL. Git clone repository URL. What is the difference here? So when we use first command, which is the git pull origin master, what will happen? Only files will be pushed. Only files will be pulled into local. Only files. Pulled to local. But whereas second one, entire repo will be pulled. Right? So here, entire repository will be pulled into local. So when we use the second command, clone command, first command is only files will be pulled into local. Second command, we can clone entire repository. There is a slight difference here. Okay. So instead of pulling the files, we can clone entire repository also. Clear, right, everyone? We'll show you practically. Yeah. Now, let's go back and check it out. Git clone. Git bash here. Now, git init here. Now, the command here is git clone Give the repository URL. Copy the repo URL. Paste it. Enter. Now it is cloned. Entire repository is cloned into my local. Now if you check ls, look at here. This is the repository. DevSecOps 114 is the repository. If you want to check the data, this is a folder, right? cd DevSecOps 114. Now you can give ls. This is the code. This is the code, right? These are the files available. 6 files are available, right? Go and check here. 1, 2, 3, 4, 5, 6. Yes. Same data available, right? ls-l. Look at here. So file name also can check. So date and timestamp also can check. Right? There is a slight difference here. Clone and pull. Clear, right, everyone? Any questions, anyone? So far, any questions, anyone?
When we will go clone and when we will go?
As per the requirement. As per the requirement. As per the project team requirement, we can use clone, we can use pull whenever required. Okay. Yeah. So one more small important one is available, which is the concept, which is fork. Okay. So with this, we are going to complete the Git concepts. Okay. So Git will not be completed until course completes. Okay. Because end of the course also, we use project. We work on project. By the time we require Git. Okay. And also while working on Jenkins, also Git required. Fine. Yeah. Now, yeah. So concept here is fork, Git fork. So what is fork? What is fork? What is the importance of fork? Look at here, everyone. This is the fork, right? This is the fork. Yeah. So why we required fork? So normally in public repo, for example, whatever the data available on your repository, I can access the data. I can access your data. When I fork it, I can access your data. Okay. So for example, look at my screen, everyone. There is a simple web app application. There is a simple web app repo is there in my GitHub account, right? This is a repository. This is a real code. In this repo, I have real code. A real code is available here. Click on this. Look at my screen, everyone. So this is HTML code. So in this, there is a master branch. So SR says source repository. Click on this. So in this, there is a index.jsp. Index.jsp. Click on this. Look at my screen, everyone. So this is the HTML code. Look at here, everyone. We can use this code for practice. We can use this code for practice. So everyone fork this code. Everyone fork this code. How can you fork it? I'll show you that. Okay. So look at my screen, everyone. Already 155 members forked it. Already 155 members forked it. Okay. So now I'll share with you this URL. I'll share with you this URL in the chat. You just open and click on save. Click on the URL and submit. So complete that. So that what will happen? This repo will be added to your GitHub account. While practicing, you can use this code. Okay. So now, yeah, I'll share this repo URL, the chart. So everyone, can you open this URL? Everyone, can you open this URL and fork it quickly? So here, already 155 members forked it, right? So once you forked it, this number will be changed. This number will be changed. Can you fork it, everyone? Currently only 155, right? So once you fork it, yeah, look at here. Someone forked it, 156. Others, can you fork it, everyone? The people who are using laptop. Only one guy forked it.
Yeah, we forked it.
Okay. Yeah, okay. So others, can you fork it? At least 2 members. This number will be changed.
We need to click on that one, right? Fork.
Yeah. Click on the link and click on fork and submit.
It is asking create fork.
Yes. Correct.
Okay.
So 156. Yes, 157.
Yeah.
So others, can you fork it quickly? 158. Yes. Yeah, only 3 members forked it. So this repo will be added to your GitHub account. So tomorrow onwards, you need to use this repo for practice. I'll show you that how to use. this repo. 159, 4 members. So one more guy, at least one more guy. This will be 160. Yeah. Only 4 members forked it. Okay, anyways. So others, if you are using mobile currently, you can fork it tomorrow. Okay. Or after this class, you can fork it. Once you log in into your laptop, you can fork it. Fine. Yeah. So this repo is having proper code. This repository is having proper code. This code we can deploy. While working on CI/CD pipeline project. Okay. While working on CI/CD pipeline, we can deploy this code on Tomcat or JBoss server. Fine. Yeah. So time is 8:50, right? So Jenkins, we can start tomorrow. Okay. So tomorrow we'll be having a session at 7:30 p.m. IST. Is it fine for everyone? 7:30 p.m. IST. Yeah, 7:30 to 9:30 tomorrow. So in between the session, we'll be having a small 5 minutes break, 5 to 10 minutes break only. Okay. Yeah. So tomorrow, make sure everyone join at 7:30. Okay. So I'll send you notification on the Google Classroom. Okay. So make sure everyone join the session at 7:30 p.m. IST. Fine. Yeah. So make sure everyone practice Git concepts. So far, whatever the concepts we discussed. So these are all the concepts which are very, very important concepts. Okay. So we'll get the interview questions. So everyone practice these concepts. Okay. So as a DevOps engineer, we require Git. We need to understand Git. We need to guide the developers. We need to guide them. We need to correct them. Sometimes they do mistakes, right? So that is why make sure everyone practice. Okay. So tomorrow by 7:30, we'll start the session. We'll start Jenkins tomorrow. Okay. So tomorrow, first hour, 1 hour, Jenkins introduction, Jenkins installation configuration, Jenkins console overview. So after that, we'll work on Jenkins plugins, jobs, different concepts are there. Jenkins is completely GUI, graphical user interface. Fine. Yeah. So we can stop here. Any questions, anyone so far?
That branch you removed from remote.
Yes, remote repository, correct.
Yeah, branch and repository both are same.
Repo is different, branch is different. Under repo, we get the branches.
Okay.
Okay.
Can we remove branches from CLI also?
Yeah. CLI also we can remove. I'll provide you all the commands. I'll provide you a document. You can check it out. Okay. Fine. Yeah. So we can stop here. Fine. So tomorrow we'll connect at 7:30 p.m. IST sharp. Okay. I'll update in the Google Classroom. Same meeting link. No changes. Okay, fine. Yeah. Thank you all.